Hey, so hello everyone. Welcome to the free crash course on Python. So, my name is Chen Hao, and today I'll hope to teach you guys the logical building blocks of coding, right? Coding in general. So, in general, you can when you learn one language, the logic stays the same across different languages. What this means is that sometimes you might hear people say some person know like 18 languages, but actually, at the heart, right, coding is about logic and these logical building blocks. So if you know the logical building blocks, it's easy to translate between different languages. And for and so it'd be right to say that if you learn Python well, right, and you know the logical building blocks of Python, it's very, very easy for you to learn another language like let's say Java or C++ or JavaScript, things like that. So that said, Python is in my opinion, is the easiest language to learn because the syn the syntax is quite simple in the sense that it looks a lot like English compared to other languages where you need to use funny symbols like curly brackets. So that's why we're starting with Python. But once you learn Python, once you know the logical building blocks, the logical aspect of coding, right, it's very easy to learn other languages. So you can think of these lessons as teaching you the logical foundations, right? So you can springboard into other areas of our coding. So yeah, so without further ado, what is Python? Roughly speaking, um, what is programming in general? Roughly speaking, programming is about giving the computer a sequence of instructions, a sequence of commands to execute, right? And the computer will do this in a very execute the commands in a very systematic manner. And these commands are made out of few logical building blocks. And so that's what I'll talk about in this crash course. So the logical building blocks which um I'll cover today are variables, conditionals, functions, loops, and lists. So you can think of it like Lego, right? All these five key building blocks are like your small Lego pieces. And writing a program is piecing together these Lego pieces to build something bigger, right? Build something more grand, right? And if you build a huge Lego structure, right, that's what computer scientists call an algorithm, right? So algorithms can get quite big and complicated, but logically, right, the building blocks of these big complicated programs, right, these big websites, the logical building blocks are still these Lego pieces, these five concepts, right? Variables, conditionals, for loops, and so on. So I think creating an algorithm, constructing an algorithm from these logical building blocks is it can be quite challenging, right? That's why people major in it. But understanding these logical building blocks, in my opinion, is actually very simple. And I hope that by teaching you guys these logical building blocks, it can spark your interest. And if you know if you're if you feel like putting together these logical building blocks is quite fun, right? Then actually you've struck jackpot because if you find this putting together these pieces fun, then essentially you kind of like programming, right? And from there you can springboard into other areas. So the goal of these lessons is to introduce these logical building blocks because I believe that these are the foundations for going anywhere else, right? You can springboard from here to any other field you like, whether it's machine learning, AI, website building, app development, game development, and so on, right? Or whether you can just use it as a daily tool, right? If you do like Excel programming, these things like that. Okay, so here's how it goes. So usually if when I teach in person, right, in physical lessons, I would have three components to it. I'll have the Kahoot exercise, which I'm gonna give you guys now, right? I'll have a few Kahoot quizzes. And then after the Kahoot quizzes, I would also give you guys a chance to do some replit exercises, which means in-class exercises, which means that you learn how to you write your own code, and then I'll go around helping you guys solve your errors. And then after that, I'll also have a website building. So there's usually three components. But the replit exercises and website building, unfortunately, is ideal to do in a physical scenario where I can look at your computer and tell you how to fix your errors. So because it's an online setting, I've tried before, right? But it's really difficult to pull it off. The engagement is just not there. So for this crash course, right, I just plan to give you guys all the most of the Kahoot quizzes, right? Crash course you guys on the Kahoot quizzes, and hopefully at least you can learn the logical building blocks. So usually the three components, right? Kahoot is meant to get you to Kahoot is where you copy the code, right? Where you copy the code, you get a bit familiar with the concepts and the syntax. Then the replit exercises is usually where you start to need to write your own code, right? So the first time is you copy, second time is you write your own, and the third time and the website building is meant for you to see real life applications of the concept you just learned to building a website. So unfortunately, because I cannot have the other two components, right? Um, I hope that you at least can take away the key concepts of the logical building blocks from these Kahoots, right? And if there's enough interest, you guys can DM me. I might be able to book a classroom where we can possibly hold a physical lesson, right? But I hope at least you guys can learn a thing or two from these Kahoot lessons. So anyway, enough briefing, right? Can I invite you guys to get started on the practical? So I send the Replit link, right? This link in the Zoom chat. Just take a look at it. I'll send it again. And can I invite you guys to open it up? Right. So once you open it up, you see something like that. Click sign up to code in Python, right? And then once you click sign up to code in Python, you see something like this. Right. So you can sign in with Google and stuff like that. And once you see something like that, you click create repo. And once you're there, right, you see 3 panels pop up, right? This left one is just a files, so you can ignore it. The middle one over here is where we usually write code, right? But we won't be writing it here for now. Right. Actually, right now, I want you guys to look at the right panel, go to shell. And when you see shell, you should see something like that, right? Your words here might be a bit different, but it's okay. Then you type Python, right? So what is a shell? The shell is currently what is this mode of coding we're coding in? What's this mode we're coding in? Is known as a interactive prompt, right? Meaning that right now we see Python. Okay, I'm gonna zoom in a bit. So I'm gonna minimize the left side, and I'm gonna zoom in a lot. Okay, so right now, if you see something like this, can I minimize this? Yes, I can. Okay, so if you see something like that, right? When you type Python, go to shell, right? Go to shell, you type Python, and you see these 3 arrows. Right now, Python is waiting for you to input a command, right? So I said programming is a bunch of commands that you give to the computer. So um, so I'll give you guys a command to write later, but later when I show you guys the Kahoot slides, right? When I give you guys Kahoot slides, I would like you guys to type it in here and press enter, right? So for every line of command you write, press enter. And don't worry if it's a bit confusing, but okay, so now it'll make sense later when we see the questions. Okay, so now can I invite you guys to join the Kahoot? I'll send it the Zoom link also. Yeah. So yesterday, sorry about yesterday. It turns out I think Windows is a bit funny. Yeah, Windows is a bit funny. You guys should be able to. Okay, yeah. So join whenever you're ready. Um, Yesterday Windows was being a bit funny. So for some reason, Kahoot doesn't work on Windows, but I'm using a different operating system now, so it's fine. Okay, so I'll just wait for 8 participants. So there should be 8 people. If you're not joining, if you're on your phone or something, I'll encourage you guys to join on the laptop, right? But it's still okay if you if you if you don't have just let me know in the Zoom chat so I won't be waiting for you to join the Kahoot unnecessarily. Okay, great. So 5 out of 8. Hope you guys have had your lunch. I mean dinner. Okay, great. There is 7 people. Is Am I still waiting for anyone? If you're not joining, just drop me a just drop a message in the Zoom chat. Okay, great, awesome. Right. Okay, so let's begin. Okay, so the first concept we're gonna learn today is variables. So so when you see this screen, right? Okay, for this is just a waiting room for people to once you're ready, once you see this screen, right? Once you see this screen, please click I'm done. And then that's how I know you guys are ready to code. Okay, so I'm gonna do a split screen over here like this. I'm gonna do a split screen like this, right? So you should get to this screen. And how you can get to it, if you guys didn't catch what I said just now, open the first link I sent in the Zoom chat, and then sign in and stuff. And then when you see something like that, right? You see 2 panels. You should see 2 panels. One is main.py, one is console and shell. Go to the right one. We're interested in the writing code in the right one for now, right? And then minimize the left side. Or you can just keep it like this. Actually, that works too. Um, but I'm gonna minimize it so that you guys can see clearer. Okay, so yeah. So if you need any, oh, can you send the link again? Sure, sure. The Replit link. Okay, I'll send the Replit link again to everyone in meeting. Here it is. No worries, take your time. You see, I gave you guys a lot of time so that there's no rush. Okay, for those um who want to be a bit more and who I can give you guys the link to, I'll drop the link to all the slides. Okay, but I must caution you, the slides are, these are just Google slides, but not all of them are used. And some of them are, most of the content is actually in the Kahoot. But if you want to browse through these concepts, you can just look at it. Okay, great, awesome. So let's begin. Okay, very good. Okay, so first concept. Okay, so just type the following thing in Replit. Okay, so because it's the first one, I'm gonna show you how to do it. Right. So when you see these like commands of these lines, right? There's two lines over here. So you write the two lines in your shell over here, in your interactive console. So you write x equals to 5, press enter, right? That's one command. When you press enter, that's you're sending Python the command, right? When you type finish the line, you press enter, you're sending Python the command. And then after you write print x and you press enter. And whatever output you see, right? Whatever output you see, you choose it in the Kahoot options over here. Okay, clear on what to do? Okay, so I'm going to I recommend you guys, if for your convenience, right, you can open like the left panel to be zoom, right? You can split the screen so that left panel is zoom and right panel is your Python console, right? This way you can see, and you can see the code and you can type it very easily. But for me, something like what I'm doing right now, right? But I'm going to actually expand this. Oh, sorry, I'm going to expand the Kahoot so that you guys can see, because I know when I share the Zoom screen on what you see over here is the Zoom screen. And if you see the Zoom screen, if the Zoom screen itself is split, then it's a bit hard for you to see the code. So I'm gonna maximize it like this so that it's bigger for you. And then when I switch the tab over, that's when I'll okay, so take your time. When you see the output, yeah, awesome. Okay, great. So oh, okay, thanks for telling me. Okay, okay, sorry. So what I said just now was, um, okay. So when you press and when you go over here and you press enter, you see 5. Then that's why the answer is 5. Okay, and you congrats, you just wrote your first two lines of code, right? Very good job. So what's happening over here is, when you write x equals, you just created a variable, right? When you write x equals to 5, you created a variable with the name of x and you set it to equals to the value of 5. So you might heard of the concept of variables in math, right? Usually in variables in math represent an unknown value. So usually you write, let's say x squared plus 2x plus 1 equals to 0. And then you're looking for the unknown value that satisfies this equation that makes left-hand side equal to right-hand side, right? And then you say, oh, x equals -1 after doing some arithmetic. That is the notion of variables in math. But for now, when you learn coding, I want you to forget this notion about variables in math, right? Because variables in coding is completely different, right? Variables in coding are not unknown values, right? Variables in coding are containers of information. And you can kind of think of it as a cardboard box, right? So imagine I have some cardboard box over here. And when I create a variable, let's say I create a variable called x. I'm labeling the cardboard box with the name x, right? The x is the variable name, is the name of the variable. And when I set it equals to 5, right, I'm opening the cardboard box, putting 5 inside it, right? And that is my container of information. And then when I print when I print x being the name of the variable I just created, then naturally inside the variable contains 5, right? So whenever I access the variable, you can think of it as opening the cardboard box and looking at inside the cardboard box and asking what value is inside, right? You're reading and assessing the value of the variable. Okay, so variables are containers of information, and yeah, so that's there's variables. So just to make sure that you have understood, I have a very similar situation over here. If you're unsure, right, please type it in the Python console. Please type these two lines of code in the Python console and select the correct answer. If if you're if you're waiting for, okay, awesome. Okay, so um oh, I think, okay, so 6 responses. Okay, so what happened over there was you created a variable called y. So I write y equals to 3, print y, the answer is 3, right? I think that's kind of expected. Um, so over here, when I write y equals to 3, I create a variable called y, right? With the variable name is y, and I put inside the variable, the container of information, the number 3. When I print y, you see the answer is 3. Okay, simple enough. So in general, you can name your variables anything, right? For example, if I want to name meow equals to 4, then I print meow, yeah, so I get 4. So you can name your variables anything, but there's a few naming rules, right? So one of the rule, the first rule is that the variable name must be one word, right? So I cannot have, let's say, high space score equals to 3. If I write that, right, you're gonna see that they complain that it's 2 words. Basically, it's invalid syntax, means that Python is complaining that my line of code is not correct. So it must be one word. And so usually if you want to like have the idea of having two words as your variable name, people usually put underscore. So for example, you put high underscore score equals to 10, then you print high underscore score, you get 10. And yeah, and that's the first rule. So the variable name must be one word, but one word, but you can name it anything you want. Okay. And another rule is that variable names are case sensitive, right? So if I created a high score variable here with the value of 10, right? But if I create a high score variable with a capital S instead of a small s and set it to 20, then high underscore big S score will be 20, right? And this distinct, that's different. That's a different variable from high underscore score with a small s, right? So variable names are case sensitive, right? That's what we call case sensitive. It's sensitive to your capitalization. Okay, any questions so far? Okay, so congrats, you just created your first variable, right? But we can do more with it. So let's take a look at the next question. Okay, so the previous 2 lines of code, you have already written it, right? So you just need to write the next 2 lines. For those who have already inputted your answer and are waiting, maybe you can either take a look at the slides, or you can write your own lines of code, right? So you can play around with the interactive environment, right? You won't really mess it up, right? So don't worry about that. So play around with the Python console, create your own variables, just have a bit of fun with Python and exercise your creativity. Okay, awesome. Okay, so so most of you inputted 4.15. So let's demonstrate what happens, right? So if I set y equals to 3, I print y, I get 3 just now, right? This is what we wrote just now in the previous question. If I set y equals to 4.15 and I print y now, then I'm gonna get 4.15, right? So what have we done over here? So what we just did was we replaced the value of y, right? The variable y. We replaced the old value of y, which was 3, with the new value of 4.15, right? So the first key concept of variables, you've learned that variables are containers of information, right? Now you've just learned that variables can change in value, right? Variables, as the name suggests, they are variable, right? Their value can change. Okay, so when I write y equals to 4.15, Python takes y equals to 4.15 as a command, right? It takes it as a command. And what does it do? It dumps out whatever old value of y there was, right? It takes a copy box, throw it in the trash, throw the contents in the trash, and now it takes whatever is on the right hand side of the equal sign and puts it inside the variable y. Okay, so whenever you write y equals to something, right, you're replacing the old value of y, you're discarding it and replacing with the new value on the right hand side. Okay, any questions? So first concept, variables store information. Second concept, second sub-concept, variables change in value. Okay, and the whole point of it is that you can use variables to change to keep track of, let's say, the score in your game, right? Let's say your high score in the game, you can have a variable to keep track of that information, and sometimes that variable will need to change in value when your high score is updated, right? When it's increased, then yeah. So variables store information, and the information, the variable, the variable storing information can change in value. Okay, so this is just another similar to the previous one. So usually I'll have like a a Kahoot slide, and then I'll explain what's going on, and then next Kahoot slide usually I'll test your knowledge to make sure that to reinforce the concept. Okay, so now I tried putting in a variable with y equals to 0, 1, and the system stated that leading zeros are not permitted. Why is this the case? Okay, that's a good question. So, okay, so I'll just split the screen over here. If you put y equals to 0, 1, leading zeros in decimal are not permitted. Okay, I guess that's just a rule. Yeah, that's just a rule. I've never really encountered this before because I've never really tried this. But yeah, just think of it as a rule that Python follows. I don't think there's a particular reason for why this is so. I think they just don't want you to have redundant because it could lead to bugs, right? It could be misleading, perhaps. Yeah. So good question, right? Awesome question. Keep the questions coming. Okay, sorry about that. Let me just open this one again. Okay, so good that you're experimenting different stuff, by the way. It's awesome that you guys are trying new things, trying different lines of code, right? So write your own variations, and if you bump into any errors, right, drop it in the chat and I can yeah, if you run into any questions, let me know and I can answer them now. Okay, awesome, right? So I think that's simple enough, right? You replace y with 2, then you print y, you get 2. Okay, so the new concept, new sub-concept. Okay, so create a variable with the name of score, set it equals to 1, and then after that, right, write score equals to score plus 10. Okay, awesome. Looks like you guys all wrote the code and you guys all got it correct. Right, so you get 11. So what's happening over here? Okay, so you write score equals to score plus 10. Your score equals to 1, and your score equals to score plus 10. Okay, and you print score, and the answer you see is 11. So what's happening over here is I want to emphasize that in math, right? I want to emphasize that variables in math and coding is different. And I use this example to illustrate it because in math, you write an equation like x equals to x plus 10. The mathematician will tell you you're crazy because there's no such value of x that satisfies this equation. There's no value of x that makes left hand side and right hand side equal. Right? But in coding, you see Python didn't complain that you write some variable equals to variable plus 10, right? And this is indicative of this is this emphasizes the fact that in coding, the equal sign is not an assertion that the left-hand side and right-hand side are equal. Right? The single equal sign, one single equal sign, is not saying left-hand side must equal the right-hand side, unlike math. Right? And in coding, instead, the equal sign is a reassignment of a value. Right? Whenever you write a single equal sign in Python, the left-hand side of the equal sign must be a variable name. Right? It must be a variable name, and the right-hand side of the equal sign must be a value. And in this case, what we did over here in the second line of code, score equals to score plus 10, was we incremented the value of score by 10. And this concept is important because even though we see score appear, the variable score appear on both hand or on both sides of the equation, they take on different meanings. So on the left-hand side, you're saying the variable score is going to have a new value, right? And it's going to be set to equal to the whatever is on the right hand side. And what is on the right hand side is going to read the value of score, which is 1, and add 10 to it. So essentially, this second line of code becomes score equals to 11, right? Because when you see score on the right hand side is a reading the value of score, is assessing the value of score. When you see score on the left hand side, you're saying this, I want the whatever value on the right hand side to go into the variable on the left hand side, right? And remember, whenever we replace a value of a variable, we discard the old value. So the 1 is forgotten after score is set to 11. Okay, so this is key concept, right? And so the next quiz will be a reiteration of the same point, right? So now if you write score equals score minus 4, what should you get? So you can see that using this concept, this is how your, like, let's say you're writing a game, right, where every once in a while your score will improve. This is what a line of code in the game would look like. Score equals score plus 10. That would increment your score by 10, right? And yeah, and perhaps later on we'll talk about um things like conditionals. Then you say something like high score equals score, right? When you want to set a high score to equal to the score. You can see that variables are containers of information that they let you store stuff, um they basically let you shuffle around information. And using code like that, right? When you write score equals score plus 10, it whatever previous value of score it was, right? Whatever previous value score had, right? It just got incremented by 10, right? Whether it's the score initially was 1, then it became 11, or whether it's 2 and became 12, right? Um, writing score equals score plus 1 will just increment score by 10, and this kind of concept is this is the kind of logic that goes on inside your video games. Okay, so waiting for one more response. Yeah. No worries, take your time. Any questions, just drop in the chat also. Okay, so time's gonna run out soon. So any questions? Sometimes it could be because the Kahoot is lagging also. So I'm not sure if the person just hasn't inputted his or her answer. But if your Kahoot is lagging, then usually it will not register as an entry also. So that's unfortunate. Okay, anyway, um yeah. Yeah, I think for the coming questions, if it reaches, let's say like 150 seconds, I'll just ask whether anyone needs more time and I'll press skip. Right. So that I don't waste too much of your time. Okay, so great, you guys all got 7. Right. So once again, if I think you guys get the idea. I write score equals to score minus 4. That decrements the value of score by 4. Right? And the current value of score was 11, right? It's not 1 anymore, remember? It's 11, right? The state of score was 11 was 11. Decrement by 4. So you print score, you get 7. Okay, awesome. Yay. Okay, great. Okay, so next concept also emphasizes the difference between math variables and coding variables. Okay, so I think I'll wait until around 150 seconds like that. Right, then I'll ask if there's enough answers. I'll ask if you guys need more time. Okay, great. So you guys all get error, right? Okay, so if I try to write x plus 1 equals to 3, I get error. They say, oh, cannot assign. What are they saying? Right? What are they saying? They're saying you cannot assign to expression here. Maybe you meant double equal sign instead of single equal. We'll talk about double equal sign later in conditionals. But what this is saying is basically, right, this emphasizes the fact that in programming, whenever you have an equal sign, the left-hand side must be a variable name, right? X plus 1 is not a variable name. X plus 1 is a value, right? So in math, you say, oh, you minus 1 on both sides and x is equals to 2, and x equals to 2 makes the left-hand side equals to the right-hand side, right? There's a solution to the equation. But remember, this is not math. This is programming where the equal sign means a different thing. The equal sign doesn't mean that left-hand side must equals to the right-hand side. The equal sign in programming means that um, I'm assigning a new value, the right hand side new value, to a variable on the left hand side. So on the left hand side of the equal sign, it must be a variable name. In this case, Python is saying you cannot assign x plus 1 because x plus 1 is not a variable. Right? X is a variable, x plus 1 is not. X plus 1 is a value. Okay. So that's why I cannot assign. Okay, any questions? So this just emphasizes that fact. And I think there's one more that emphasizes this concept again. Yeah, so if you're unsure, you can type it in, right? But if you are quite confident, you can just answer it also. Okay, so I think I'll wait until maybe 180 seconds. Okay, awesome. Right, so you guys had error just like just now, right? I think you guys get the idea. Okay, so next concept. Okay, so now we're starting to do arithmetic with variables, right? So I create a variable called a and I set it to equals to the value of 3. I create a variable called b and set it equals to the value of 2, and I set c equals to a plus b. Right. So this once again emphasizes later on a concept, right? So you can plus minus times divide with variables, just like yeah, you can do arithmetic with variables basically. So you can kind of treat Python like a calculator, right? You know, sometimes if you are in if you use your calculator, right, scientific calculator or graphing calculator, you know you can set certain variables to be some values, right, that can help your calculations. So you can kind of think of it's actually basically the same concept, right? Setting the variables in your calculator to to take on certain values is similar to setting variables in Python. So Python is more powerful than the calculator. Okay, awesome. So you guys get 5. I think, should I demonstrate this? I think I should. So let's say I'm going to clear the screen. Clear the screen. A equals to 2, B equals to 3, C equals to A plus B. Right hand side of this equation is 2 plus 3, which is 5. So this is essentially saying C equals to 5. And after I print C, and I get 5, right? So, okay, so now the next one might be a bit tricky, right? So I invite you guys to type it out, right? Even though you might think you can guess the answer. Right? If I change the value of A to be 1, right? Now what's the value of C? Okay, awesome. Okay, so yeah, usually someone will answer 3, but the correct answer is 5. Okay, actually just now, I think I might have swapped it around. A equals to, yeah, I might have swapped it around. Let me just write A equals to 3, B equals to 2, just for the sake of following the slides. Print, right? So to avoid any confusion, print C. So matching so far, right? And then after that, I write A equals to 1, and now I print C again without changing. I didn't type C equals to A plus B again, okay? I only typed it once before I reset the value of A. And now when I press, you see I get 5, right? So you may be wondering, wait a minute, didn't I tell Python that C is supposed to be A plus B? And if A is 1 and B is 2, shouldn't the new value of C, I change the value of A to become 1, shouldn't new value of C be 3? And this is a common pitfall, right? So this example emphasizes the fact that uh every line of code that you write to Python is a single command, is a single instruction, it's something imperative, it's something that you tell Python to execute once, and then after that it doesn't look at it anymore, right? Every single line of code that Python executes, it just executes it once. So when you write C equals to A plus B, C equals to A plus B is not a formula for C, right? C equals to A plus B is saying, I want to set the variable C to equals to whatever's on the right hand side, which in this case, at that point in time was 5. So this line of code is C equals to 5. And after you write C equals to 5, you press enter, you print C, you get 5. C stores the value of 5. And for all purposes, right? For all purposes to Python, whenever after you run this line of code, you press enter, the only thing that changed, the only thing that remained, right? The only piece of information that stayed essentially was the new value of C, right? Python doesn't care how you got the new value of C. It doesn't care if it's A plus B or whether it's 1 times 5 or whatever, right? It only memorizes the current value, the current state of C. So when we write C equals to A plus B and press enter, that's not a formula for C. That is a instruction, that's a command to Python to change the value of C to whatever is on the right hand side of this, A plus B, right? And once it changes it, right, that command is executed, is done, right? So when you reset the value of A is equal to 1, right, you did not change the value of C. So C was still the old value. So that's why the C is still 5, right? So everyone clear on that, right? Any questions? This is quite a key idea that trips up quite a lot of first timers. Okay, and so question now, what if let's say you want to change the value of A, then you want C to be updated, right? Then after that, then you write another line, C equals to A plus B, right? And you press enter. There's another instruction to change the value of C to equals to A plus B. And now when after you execute this line, when you write it a second time, right, it reads the current value of A, it reads the current value of B, and then it sums it up. And hence, if you execute C equals to A plus B and print C again, you get 3. Okay, everyone clear on this example? Right? So this example emphasizes another difference between coding and math. In math, your formulas are symbolic. You're saying C is equal to A plus B as a expression, right? But in coding, your C equals to A plus B is a single command that's executed once, right? And when A changes, if you don't write C equals to A plus B again, the C doesn't change. Okay, everyone clear on that? So yeah, so this is another conceptual aspect of variables that is important to emphasize. Okay, so with that, right, we've done most of we've covered most of uh concept of variables. You can do arithmetic with variables quite simply, like a divided by b. You can create variables called pi and radius, right? And you set area equals pi times radius and radius. So you can see you can kind of build like a small calculator of sorts, right? And your order of operations follow math also, right? So like 5 times a plus 6 bracketed, right? That means that you do a plus 6 first. Then if you there's a small difference, right? In that the percent sign in coding means remainder. So let's say you do 5% 2, that means 5 divided by 2 leaves a remainder of 1, right? We call it modulo. So 5 modulo 2 is 1, right? So with that, to conclude the lesson on variables, I'm just going to have a few true or false questions for you to answer. So no typing of code in this case, 20 seconds, just to recap on what we have learned. Okay, awesome. So everybody got correct, right? Variable store information, that's true. Okay, so the information in variables, the information stored in variables cannot change. So this is a false statement, because if I have a variable called x equals to 2, x equals to, let's say x equals to 3. So x is a variable and store 3 inside. And then after that, I write x equals to 1, right? The value inside x has changed. So if I print x, you see there's no longer 3, is 1. So that's why this statement is false, right? Cannot change is false. It actually can change. Okay, everyone clear on that? Okay, so last question. How do I assign the value 5 to the variable x in Python? Okay, awesome. Everybody got this correct. Okay, so yeah, so remember 5 equals to x is wrong, right? Because left-hand side must be a variable, right-hand side must be the value. All right, awesome. So good job. Okay, so good job, guys. So the next concept we're gonna cover now is conditionals. So let me just open up the conditionals Kahoot. Yeah, here it is. Okay, good job to these 3 people. Congrats. But you all are winners. Everyone's a winner. As long as you learn, you're a winner. Okay, so conditionals 1. Okay, so before we move on to the Kahoot, I'm just gonna say a few words. Okay, so before we move on to Kahoot, I'm just gonna say a few words first. So this is the link. I'll send it in the Zoom chat. Okay, so just now, okay, so just now we wrote code on the right hand side only, right? Just now on the right hand side we wrote all the lines of code, one line by one line. Every line is a command to Python. It's an instruction that Python executes. But now we're actually going to do a bit differently. We're actually going to write code on the left hand side, right? So you guys have grown up. You guys are big boys and girls now. You guys are going to upgrade and write code on the left hand side. So what's the left hand side do? Right, left hand side you can write lines of code. But now realize every time you press enter, let's say I write x equals to 5 and I press enter. Okay, then ignore autocomplete. Then every line of code that you write, right? When you press enter, it's not executed immediately. Only when you press run is it executed. Right? So when you press run, every line of code that you've written is executed. So it goes line 1, line 2, line 3, line 4. right? In this case, line 2 and 3 and 4 are blank, but line 1 created a variable called x and set it equals to the value of 5. And let's say I do print x on line 2, right? So Python would run the lines of code sequentially. So let me just clear the screen, run. So we see 5 appear, right? So it makes sense because when we run line 1 and just line 1 alone, there's no output to the screen, right? It just creates a variable, sets it to 5. When you print x, whenever you print something to the screen, you see appear on the right hand side on the console, right? So if you see this shell thing, you can now close it and go over to the console and you'll be writing code from here from now on. Sorry, you'll be seeing your output in the console tab from now on. You'll be writing code on the left hand side and you press run and you see the output on the right hand side. So I just want to emphasize that you only see output when you print something, right? When you type print a variable name. If you don't print it, there's no output. So let's say I write x equals to 5 print x equals to 4 print x. 4 lines of code over here. If I press run, the output will be 5 and then 4, right? So I clear the screen, I press run, you see 5 and 4 because the line 2 would print x, and at that point in time, the value of x was 5, right? Then line 4 would, when I print x at that point in time, the value of x was 4. So it goes line 1, line 2, line 3, line 4. It executes each line by line. So just now to emphasize again, in the right hand side, just now when you type commands in the shell, in the interactive console, you are like talking to Python. You say one line, then Python maybe gives you a response back if you did some printing. Right? You talk to Python one line at a time, one sentence at a time. But now you are writing your script, right? You're writing your conversation, your entire conversation on the left hand side. And this is what we call a program or a Python script. And when you press run, Python will read through your entire script and execute each line by line. Line 1 to line 3, line 4, right? Sequentially in this order, right? That's the idea for now, right? So now in the new conditionals, Kahoot, I'm going to show you guys how to branch out your lines of code. Okay, so how to selectively execute different lines based on some conditions. Is that 7 people? Am I still waiting for anyone else? I'll just begin in around 30 seconds. If you need more time, just let me know. No worries. Okay. Now let's begin. Okay, so now the code that you're going to see is going to look a bit different. And I want you to write it on the left hand side now. So now the style is that I'm just going to illustrate for example. I'll start the Kahoot first, and then you see the first example. It'll make more sense to explain from there. Oh, okay, so I have some recap for variables. So this one isn't meant for you to type it in. It's meant to be quick. So just answer whatever comes to your mind. Maybe I should make it a typing exercise. Okay, great. So, okay, so I wanted to explain that, but let's just do the next one first. Oh, okay. Actually, I just realized before I talk about that, I need to talk about strings. So actually, I'm just gonna skip this question first. Okay, sorry about that. I just realized I skipped one lesson ahead first. That's why it might be a bit confusing. Okay. Let me start another Kahoot. That was the wrong one to go. Okay, this is the correct one. So the correct one is this one, variables words. So I got too excited and I wanted to start on conditionals already. Okay, so please join this one. You don't need to leave the previous one. You can just apologies for that. Yeah, so join this Kahoot. But the same thing I said about writing code on the left hand side, it still applies. So just that we need to cover variables storing words, right? Text information first before we talk about conditionals. Okay, great. I think everyone's here. There might be a recap again. Okay, I don't think there's a recap, but yeah. Okay, so once again, try it out. Try typing out the code, word for word, right? Including spaces, including brackets. Python is very sensitive to spaces and brackets in some aspects. So you don't type it out exactly the way it is, sometimes you get a different result. Because the computer cannot read what you cannot interpret what you want to say. Okay, so some of you guys get error, right? And error is correct because if I go over to the console over here, actually if I go over to the left hand side over here, we're typing code in the left hand side now, right? So I write print hello, and when I press run, it says error, right? When I press run, it says error, and the reason is because remember just now when we did something like print x, we are looking to print the value of the variable x, and let's say if beforehand we write x equals to 5, then we get 5, right? But right now when we want to print hello, what Python is complaining about, is they're saying I want to print the value of the variable hello, but you didn't create such a variable, right? So Python says there's no name hello is not defined, the variable is not defined. Okay, so that's what is going on now. So question is, what if I want to print text to the screen? Right? Then you need to enclose it in quotes. So if I want to see hello literally appear on the screen, what I need to type is, instead of printing hello like that as a variable name, right, I put hello in quotes, and that will tell Python. You can see Python kind of change the color of the text, the color of the code to become orange now. That will tell Python that I want to print hello to the screen literally, right? And that's why we see hello appear. So hello. So in other words, to summarize, hello in no quotes means we're looking for a variable called hello. We're looking for a variable with the name hello, right? We're looking for a cardboard box with the name hello, the container of information. If you don't create such a variable, we get error. But if I put quotes around it, we're telling Python, I literally want to see hello appear on the screen. This is what we call a string, right? Or you can think of it's what I call a string in Python. But basically a string is just text information. Okay, and if I print by in single quotes, so you can either define strings with hello with single quotes or double quotes, right? So I do print by in single quotes, this is also a string, right? By yeah, so you can define strings with single quotes or double quotes. Any questions? Okay, if not, yeah, so just like how you can store number information, right? Just how I can store number information, real numbers in variables, you can also store strings in variables. So variables can take on string values, right? They can take on text information. We can store text information. So I create a variable called x and I set it to equals to hello world, right? And I print x, right? Then I'll get hello world. So you can think of hello world as the information that you're storing in the variable x. Okay, so variables not only can store number information, they can also store string information. Okay, so I press run. Sometimes if you see the output doesn't appear, you need to click on it a bit. Sometimes it's just a aesthetic bug, right? Okay, so yeah, so if I set x equals to, if I replace the value of x with bye bye in quotes, right? Then that replaces the old value of x, right? So hello world is thrown out, right? Gone forever, and now is replaced with bye bye as a string, as a text information. Okay, so what happens if you try to add strings together? Okay, so do take note, the difference between blue and yellow is the spacing. So if I create a variable called x and I set it equals to cat says, and I create a variable called y and I set it equals to meow, right? And I do x plus y, what will I get? Difference between blue and yellow is the spacing. Hey, awesome. So I see one of you have put blue, right? So if I do it literally, you print it out, you see cat says meow, the first picture over here. And can you tell the difference between the two different code snippets over here? The top one is cat says meow with no space, the bottom one is cat says meow with a space. And the distinction is that when I define a string, right, if I put a space in the string, it's taken literally as a form of text. So the space in a string, right, the space in the text in the text content, right, when you put it inside quotes, the space in the string matters, right? It matters whether the space or not, because to the computer, the space is just like any other character, just like your alphabet, right? A, B, C. So yeah, that's a key distinction. So now you know how to add strings together. It's what we also call concatenation, where we put two strings side by side. Okay, so question now, what if I have a number multiplied by a string? What would that do? Yeah, I'm gonna let it run until 170 seconds. Okay, awesome. So everyone sees meow meow meow, right? So when you do multiplication of a number and a string, you just get the string repeated many times. Okay, this one is a bit tricky, perhaps. So you print you are 8 years old. I'll let it run until maybe 180 seconds. Okay, awesome. So you guys see you are 8 years old literally appear. And why is that so? So if you may be wondering, wait, what if I want to say you are 12 years old instead of you are 8 years old? What would that look like? So, okay, so we have age equals to 12 and print you are 8 years old, right? With the Y. So you print you are 8 years old. When we print this, you see literally you are 8 years old appear, and that's because Python sees you are 8 years old as a text information, and it's inside quotes. So it's taking that information literally, right? But the intention, this doesn't make sense as an English sentence, right? Usually when you say you are 12 years old. So if our intent, right, if our intent is to say you are 12 years old, where this age is meant to be the value of the variable age, then we need to do something a bit different called a formatted string, right? So yeah, so this is what we get. Age is part of the text, right? This age is part of the text and it's not interpreted in Python so far. It's not yet interpreted as a variable. Then what do we need to change in order for it to be interpreted as a variable? You need to do this thing called formatted string, where you basically you put f before the start of the string, right? Before the starting open quote. Then after that, you put curly brackets around the variable name, right? You are 8 years old, and when I press run, you see that now you are 12 years old. So what has happened over here is that I created a variable called age and I set it equals to value of 12, right? What we did in the first lesson. Then I print formatted string. This f tells me is the formatted string, and then I put open quotes and close quotes. And inside here, I write whatever text I want, except whenever I want to read literally the value of a variable, right? And I don't want the variable name to appear as appear in the string as a literal text information. I want to tell Python, I'm not looking to print age to the screen. I'm looking to print the value of the variable called age, right? Then I put it in these curly brackets, and that would help me tell Python. You see the Python also, the IDE, right? The Replit has also been very nice to us in that it color coded it for us, telling us, oh, this age is in white color. It's different from the rest of the string. Okay, so everyone clear on that? Right, so this is formatted strings. Okay, so now on the topic of variable type conversion. Okay, so let's give this a try. Okay, that's a very good question. Right, so Angeline asked, is this equivalent to print UR plus age plus years old? That's a very good question. So, okay, while I'll split the screen here, while you guys are typing this out, I'll just write what just wrote over there. Okay, so UR plus age. Okay, so this is literally what you wrote. Actually, this ties in very nicely with this Kahoot slide. So if I try to run this, I'm actually going to get an error, and I'll explain why very soon. Right? This Kahoot quiz actually explains it, and I'll tell you how to fix it later so that you get the intended output. Okay, so mixed answers here, right? The answer is actually error. So you tried it out. Now let me see. So if I show media, and I try it out. Yeah, I'm just gonna delete those two lines first. X equals to 5, y equals to high, right? And I print x plus y. So good guesses, right? But this was meant to be tricky, right? So, oh, sorry, I got it the other way around. So this should be x, and this should be y. High and 5. Yeah, okay. So if I try to run this, I get an error, right? So I get an error. And what is this error telling us? This error tells us, okay, so along the way, when you see errors, you always try to read the errors, but when you read it for the first time, it's gonna be a bit cryptic. But after a while, you learn how to sieve through the noise and read what is important. Guess when I run this, you see trace back, blah, blah, blah. You can ignore all these two lines, read the type error, right? Read the error. They say line 3, right? Line 3 is an error. Line 3 meaning this print xy line, print x plus y line. And they tell us the line, then type error. So they're telling the type of the error, right? Oh, it's actually called type error. Can only concatenate string, not int to string. So what this means is that if I go to the next slide, you see I get this error. And what happened over here is that if I print the type of the variable, so to find out the type of the variable, I can put type bracket x. So now I print open bracket type open bracket x close bracket close bracket. Okay, so this is called a function. More on that later. But if I do this, 2 lines of code, line 3 would print the type of the variable x, and line 4 would print the type of the variable y. So now we're talking about the topic of variable types. So what's the output I see? We see that x is the first output corresponding to line 3 is saying that x is a string type of variable, right? String meaning text information. And the second output corresponds to line 4 is saying the type of the variable y is a integer variable. Integer meaning number, right? As you know, the integers are 0, 1, 2, 3, 4. So what this means is that when I try to add x plus y, right? When I try to add x plus y, they're telling me I cannot add a string to an integer. And the reason is because if the reason is because Python doesn't, it's a bit ambiguous, right? So it's a bit ambiguous. More on that later, right? Python doesn't know which one to convert into a string and which one to convert into integer. So you need to be explicit and tell Python, and you need to be explicit and convert the variable for Python. So what that looks like is something like that. Let's say I want to say hi and I want 5. I want 5 to literally appear as a string, right? If I do x plus str, str will convert the variable y into a string. So if I do x plus str bracket y like this, then I will get high 5 as I wanted to get. Okay, so x plus y alone, x is a string type variable and y is a integer type variable. Python cannot add words to numbers, right? Python cannot add text information to integer information, right? But if I put str around y, that will help tell Python I want to explicitly convert the y variable, which was initially which was a integer. I want to convert it into a string. And now remember just now we did a Kahoot quiz where we do cat says plus meow, right? That's adding a string to a string. And now Python is like saying, oh, x is a string and stry is also a string, right? Because str converted y from a number 5 to a string 5 with quotes. Then x plus y, no problem, right? That's why we see high 5 appear. Okay, so this is known as type conversion. Every variable you create in Python has a certain type to it, right? We have encountered 2 types so far. One is the string information, which is what x is, right? X is a variable of the type string, and y, the other one is a integer or number information, which is what y is. Y is a variable of integer type. And later on we'll see a third one, which is known as a Boolean, true or false values, and that will be used in conditionals. So to answer Angeline's question, is it equivalent to printing you are 8 years old? Right? That's a good question. So if I want to print you are 8 years old like this, right? You see that if I try to run this, again, I'm going to get an error, right? Once again, the error is saying that you are is a string, age is a number, and years old is a string. So it cannot add string to a number to a string, right? So question now, if any one of you were to suggest in the Zoom chat, right? How do you fix this how do you fix this code so that it prints you are 12 years old? If let's say I didn't want to do the formatted string, I wanted to do it using this method that Angeline proposed. Can anyone just shout it out in the Zoom chat or unmute yourself? Any guesses? strh, yes, awesome, very, very good, right? So str bracket h, and that would fix it. So now we see you are 12 years old. Okay, but oops, that's a little bit, that's not very aesthetically pleasing, right? I want to see you are, oops, hold on. I want to see you are 12 years old, not you are 12 years old, right? So any other suggestions for how do I make it a bit neater? How do I make it you are space 12 years, 12 space years old? Suggestions in the Zoom chat? Add spacing, yes, awesome. So when you add spacing, as between R and the closing quote and between years and the opening quote. So now you see you are 12 years old. Awesome. Okay. So very good questions coming from you guys and very good answers too. So yeah, this is variable type conversion. When you are at this string to an integer, you need to convert the integer to a string. Okay, so maybe a question you may be wondering is, what if I want to convert the string into an integer instead? So that's what the next question will be on. Okay, so what if I have x equals to 5 as a number and y equals to 6 as a string? Okay, so question, can a mathematical function be a variable? Okay, that's a good question. So, okay, I'll talk about functions later, but the short answer is no, right? You cannot say Okay, actually, um, okay, the short answer is okay, awesome. So all you guys got this correct, right? So okay, the short answer is so this question, can a mathematical function be a variable? Can I say variable equals to the function that squares a number? Um okay, short answer is short answer is yes, right? But long answer is a bit more advanced, right? That moves on to a topic called functional programming, and Python doesn't, right? Python doesn't support. I don't think Python supports that. Other languages do, right? So actually, okay, yeah, the short answer is yes, but it's a bit advanced. The idea is a bit advanced. That's a very good question though. So okay, so anyway, um, we see the x equals to 5, y equals to 6, and now we see an error. So question now, how do I fix this? Any suggestions? Y equals to 6, and I print x plus y, and I want to see I want to see 11 appear, right? Let's say I want to see 11 appear. Any ideas? Okay, so maybe one put int, very good, right? So that's the correct answer. Put integer. So you put int y, and then now you get 11. Okay, but maybe you may be okay. So that's correct answer, and that's what we see in the next slide. But if you're wondering, what if I put string around x instead? Can anyone guess what the output would be if I put string around x? Would Python complain? Python wouldn't complain, right? Because I'm adding string to a string. Awesome, right? So correct. You see 5, 6 appear. It looks like it's saying 56, but do be careful. To Python, this 5 and 6 is a string, meaning it's literally 5 and 6 as characters side by side. Because I'm adding, if I do string x, right, then this is essentially 5 in quotes, and then y is 5, is 6 in quotes. So I'm adding 5 and 6 as strings, which is why I see so-called 56, but it's actually more like 5, 6, right? Okay, so very good, right? Very good that you guys are aware. Okay, so if I want to, back to the original question, if I want to convert y from a string to an integer, I put int around it, and that will get me 11. Okay, so if I get error if I do x plus y just like that. If I do x plus int y, then I get 11. Okay, so this using string, using str round bracket and using int round bracket, right? You see, I can convert strings to integers and integers to strings. Okay, so that's it for Kahoot. Okay, so very good, right? Good job, guys. Okay, so we are around halfway there, right? So now, yeah, you guys have understood the basics of of variables. Let me just mention something. Okay, so usually in at this point in time, I'll usually tell you guys to do the reply exercises, which will tell you how to take in user input. But for now, I'll just tell you how to take in user input directly, because you guys are not doing the exercises. So let's say, so what we've done so far is very cool, right? But let's say, what if I want to ask the user for some input, right? So if let's say I want to say, I want to set x equals to, I can write something like x equals to input, and I put quotes, and inside this string, I can say enter your name. Okay, so maybe I name the variable name instead of x. Okay, so let's say I create a variable called name, and I put equals to input, enter your name, like this. Then when I press run, what's going to happen is Python is going to say enter your name, right? And it's now this cursor over here is waiting for the user to input something. So let's say I say my name is TCH. And I press enter. The moment I press enter, right, Python takes whatever I inputted and replaces this entire input function call, right? More on functions later, but it replaces the entire input function, this entire input statement, right, into whatever I inputted. So it's essentially line one is now when I press enter, line one is essentially saying name equals to whatever I entered, which is TCH, like this, as a string, right? As a string. So if I do, let's say I print hello plus name, right? Hello plus name. Then if I run this, if I enter TCH, I see hello TCH. If I enter cat, it says hello cat. Okay. So whatever, now you can see that using the input command, you can tell Python to interact with the user. And this is how, I mean, the computer must take some input from the users and then can process the input and output something. So this is where you can interact with the user using this input command. So whatever I type in over here, will be stored in the variable name. And after that, line 2 would print hello plus name. Okay, clear enough? Okay, so maybe instead of, so this is how you input strings, right? This is how you input strings. But what if I want to input numbers, right? So if I want to input numbers, let's say I say enter a number, right? And then after that, I say, okay, so I'm going to rename the variable to number, and I want to print 2 times number. Okay, so if I press run and I enter, let's say I enter 5 right now, right? The intention of the code, right? You can see, roughly speaking, the intention of the code is to double the number, right? But if I press run, you see that it says 55. And why is it 55? Is because, remember, I just said that when I take input from the user, it's interpreted as a string. So when I input 5, it's not taken as the number 5, it's taken as a string 5. So when I run this, right, when I multiply a number with a string, it doubles that number. It doubles the string, right? It repeats the string twice. And that's not what I want. So what I can do is I can actually say, instead of doing, if I want to double a number, I need to convert the number into an integer. So I can do this. I put int around the entire input, right? So whatever the input is, let's say the input was 5, then it's essentially doing int of 5, and then this int of 5 is essentially the number 5, right? And then now it'll work correctly. It doesn't repeat the string. It actually doubles the number as intended. So now I put 5, I see 10. Okay, if I put 6, I'll see 12. Okay, and now I've built a simple calculator. And so if another way I can do this, right? If I don't want one big line like that, I can say number equals to int number. That also works, right? So this replaces the old value of number with the new value of number, which is integer. Or if you don't like that, also you can even create a new variable, right? Or you can even do something like this, int number, right? It's all up to your preference. So there's many ways to code. Something that's logically equivalent. So if, let's say, your friend writes an assignment and he submits it, and you write assignment and you submit it, maybe your code is different, but they can be logically behaving the same way. So just like how there's many working that gets you the correct answer, right? There's a lot of different types of code that gets you so-called the intended logical workings, the logical something that's logically correct also. And this is known as implementation. So maybe your friend's code is a bit more elegant. Maybe he does it in 5 lines, but you do it in 10 lines. So that's where implementation matters, and that's where a bit of the skill is involved also. So there's different ways to achieve the same output, but the more efficient you are, the more elegant your code is, right? The more readable your code is, then that indicates that you have more skill. So that's what people are usually talking about when they say you write bad code or you write good code, right? If you write bad code, maybe it still works, but maybe it's a lot more inefficient. And yeah, so okay, so that's a small tangent, right? But what I wanted to emphasize over here is just the input, because in the next lesson, in the conditional lesson, we'll be using this input quite a lot, where we ask the user for input, and depending on what the user inputted, we'll be doing different actions. Okay, so as a lead up to conditionals, right now, every line of code that you write, right, is executed. If I print hi over here, every line of code that I run is executed, right? Let's say I put 5, I see 5 and hi, right? Every line of code, it runs sequentially, line 1, line 2, line 3. But we know that's a bit limited. That's a bit limited in what we can do. And in general, you might want to be able to run different lines of code depending on whatever the user inputted, or depending on some conditions. So for example, if you input the correct password, right? If let's say enter the password, right? And here say password. Then if I enter the correct password, I want to print something, right? If I enter the wrong password, I want to print something else, right? Then that's where we need to use conditionals. So that's what we'll talk about now. Okay. So if not, you guys should be in the conditionals Kahoot, right? We will now be switching to it. So let me just click next. you guys should still be inside the Kahoot, right? Let me know if you guys need some time to join or if you guys accidentally exited or Kahoot kicked you out. Okay, so this is just a recap, right? This is a conditions Kahoot now. It's a recap of what the previous two Kahoots about. Okay. So very good. It converts a variable into the integer type, right? 6 as a string get converted into 6 as a number. Any questions? Okay, if not, let's get moving on with conditionals. The conditionals, they let us select certain lines of code to execute. And what I mean by that, right? So let's begin with some example. So before I talk about if else statements and conditionals, I first want to talk about the concept of true or false statements, what we call booleans in Python. Okay, so you can type out this code in the replit, right? So you can write it on the right hand side. Okay, so the thing you get is true, and essentially you can either write it on the right hand side or left hand side. Let me just write it on the left hand side, right? Doesn't really matter because it's just one line of code. So I press run, I get true. Okay, so what this is saying is just simply that when I print 5 greater than 2, right? This greater than compares the left hand side and right hand side, and since 5 is greater than 2, it's a true statement. So when I tell Python to do this thing, I'm telling Python to evaluate whether this statement is true or false. Right? It's an evaluation. Okay, and the reason why it's not 5 greater than 2 is because I didn't put it in quotes. If I put it in quotes, then I'll see literally 5 greater than 2 appear like this, right? But if I put it in, I don't put it in quotes like that. It's I'm telling Python to evaluate this statement as a true or false statement. Okay, so just like how I can evaluate 5 greater than 2, I can also evaluate 5 less than 2, right? So you can either run this on the left hand side or the right hand side. Doesn't really matter. Okay, so you guys get false. Awesome. Okay, so if I change this to less than, you get false. And what if I, let's say so it's a false statement. And do note that this is different. This is distinct from printing. This is actually very different from printing false as a string. Okay, so I'll talk about this later on when we print the type of this variable. It's different from false as a string. So you see false appear like that, but it's not literally false as a string. It's actually known as a boolean. Even though when you print it out, it displays the same characters, right? But it's different from that. Okay, so this one might be a bit tricky, right? I put a double equal sign. Do take note of the double equal sign is not a single equal sign. Okay, awesome. So everybody gets true. Okay, so I create a variable called x and set it equals to value 2. Then I print x double equals to 2. And what this is doing is evaluating whether left hand side and right hand side are equal or not. Right? So okay, so remember how just now I was saying a single equal sign is an assignment of the variable on the left hand side to the new value on the right hand side. But in this double equal sign is not an assignment. This double equal sign is a comparison. Right? It's still not the same as the mathematical one where it's an assertion that left hand side must equal the right hand side. This itself can be a true statement. If I put x equals to 3, I'm gonna get false. Right? So this double equal sign is a comparison of left hand side and right hand side. And Python will give you true or false depending on whether left hand side is equal to right hand side. So if I put 2 equals to 3, I'm gonna get false. If I put 3 equals to 3, I'm gonna get true. Okay, any questions? So using this, what's the power in this? This means that we can use the double equal sign to compare the value of a variable to check whether it's equal to something particular, right? So this might be useful. Foreshadowing, it might be useful for let's say a password system. You want your password to be exactly some characters, right? Like some password. Let's say my password 123. You want your password to be exactly that. This is where we use the double equal sign. But more on that later. That's coming up very soon. Okay, so I press next, right? So once again, double equal sign is a evaluation of whether left hand side is equal to right hand side. In this case, it returns true because left hand side is in fact equals to right hand side, right? X is the value of 2, right hand side is the value of 2, both are equal. So I can also have a false statement. Oh, okay. So actually this moves on to inputting, right? So if I do x equals to input something, and then the thing that I input is high, right? No space, no caps, high, just high. Then question is what I'll get. Okay, so I'll just show you guys the code here so you can write it out slowly. You can write it on the left hand side. You don't need to write it on the right hand side. But either way is more or less the same, because when you write it on the left hand side, Python will run every line in sequence anyway. Right? So just the only difference is that when you write it on the left hand side, you can kind of so-called save your progress. Right? Whereas if you write it on the right hand side, every time you run a line of code, you press enter, you need to retype it in again if you want to repeat that line of code. Okay, so you get true, right? Okay, so what's happening over here? I write x equals to input something. Okay, and then I print x equals double equals to high. Print x double equals to high. Okay, I press run. You see that the right hand side, they're asking me to input something. If I type by, I'm gonna get false. If I type high as a string, I'm gonna get true. So if I type high as a string, high goes into the variable x. And then when you compare x and high, left hand side and right hand side are equal, right? As strings, you get true. Okay, do note that this is space sensitive, meaning that if over here I type high with a space, I press space, right? That is a different string already, right? Then I get false. So Python is quite sensitive to spaces. Just take note of that. So this is where we can compare the user's input with something, right? And that's already some amount of power now. Okay, so yeah. So now if I okay, so I also wanted to emphasize some differences. So if I write x equals to 2 like this, and x double equals to 3, and I print x, question now, what is the value of x? If I write these 3 lines of code, right? So I wrote it on the right, in the example here, I wrote it on the right hand side, so that's why I see false appear, because it's evaluation. But if you write it in the left hand side, you wouldn't see the false appear. That's completely normal. Right, print x, do I see 2, 3, or true or false? Okay, so I get 2, right? Awesome, everybody got correct. So if I question now, what does this example emphasize? This example emphasizes that this example emphasizes that a double equal sign does not change the value of x. Okay, the double equal sign does not change the value of x. It only compares the left hand side and right hand side. It's reading the value of x. It's not changing the value of x. It's only assessing the value of x. And I can also write 3 equals to x, right? No problem with that. Remember, in the single equal sign case, I cannot write 3 equals to x, right? Because left hand side must be a variable if I write a single equal sign. But I write a double equal sign, left hand side and right hand side are both values. Python will compare these two values to make sure to ask and tell you whether it's true or false, whether both are equal or not, right? But just to emphasize that double equal sign does not change the value of x. It only reads the value of x. It only compares the value of left hand side and right side. Okay, so you see x remain unchanged even after line 2. Okay, any questions? Okay, if not, that's good. So yeah. So question now, what is the output if I try to print x single equal sign 4 inside print statement? Okay, so you guys get error. Awesome, right? So correct answer. So x equals to 3, and I print x equals to 4, right? If my intention is to compare x and 4, this is the wrong way to do it because I'm using a single equal sign. Okay, so when I use a single equal sign, Python thinks that I'm trying to assign the value of x to be 4, to reassign the value of x, right? It thinks I'm trying to replace the old value of x. But when you try to do it inside a print statement, Python is angry, right? Python is like, x is an invalid keyword. Okay, it's because print is actually a function, but basically this error tells you that you cannot do this, right? If you want to compare x and 4, you put double equal sign. So this is a very, very common mistake. There's always bugs. My students always have bugs involving these kind of single equals versus double equal sign, right? And the thing is that at least Python tells you there is an error, right? In C++, in other languages, if you put a single equal sign, it's actually going to change the value of x, and it's actually going to return true. So at least in Python, they tell you that this is an error and you're probably not intending to do this, right? They tell you you're doing something very suspicious, right? But in other languages, they don't actually warn you about this, and what will happen is that even though your code can run, it's going to lead to logical errors. So when you see syntax errors like that, you know immediately there's an error and you need to fix it. You should be actually happy that you see such an error. But if you have a logical error, it's much harder to find the source of the error because your code could be running fine, but it's a logical mistake, then that would be quite a pain, right? But yeah, so anyway, the point of this example is just to say that single equal sign and double equal signs are different, right? Single equal sign, as we said in the first Kahoot, is assignment of the left-hand side, which is a variable name, to the new value on the right-hand side. I've said it a million times already, right? But double equal sign is a comparison of the left-hand side value and the right-hand side's value, okay? So the comparison in this case would be useful when we talk about conditionals, right? So that's the first Kahoot over here has, oh, okay, there's more, but so far we have learned how to compare values between numbers and strings. Okay, so someone has a question, right? Can we compare strings using greater than sign or less than sign? The answer is yes, you can. I didn't include it in the slides because there's not functionally what you'll do is you'll just compare it alphabetically. Okay, so you just compare it alphabetically. Yeah, so if you use the greater and less than sign to compare strings, you just compare it alphabetically, which might be useful in some cases, but not so common, right? So most of the time we're comparing strings, we're comparing whether two strings are equal. Okay, so yeah, take your time to write these long lines of code outside. Okay, so when you see this spacing, right, at line 3, is important. This double space is actually 2 spaces. It's important. Right? You can press a tab to have these 2 spaces. I'll talk about this soon. Okay, awesome. Okay, this one I'll let you guys take your time because it's quite a long piece of code. Okay, great. So you guys all have, most of you guys say condition is true, right? So what does it look like? So if I write this line of code out, I write condition, right? It's a variable name. I set it equals to the value. What value am I setting? Oh, it's new. It is a new value I'm actually setting it to, right? It is the first time we're seeing this value. It's known as a Boolean, but more on that later. So this condition is equal to true with a capital T. It makes a difference, okay? So what am I saying over here? This is essentially saying I'm taking this condition is a variable that stores a true value. Okay. Then if I do so previously we had strings, we had numbers, but now this is a new type of variable called booleans. So if I have condition and then I write if condition. Right. So if round bracket condition and I write a colon. And after I write a colon, if you notice, if I press enter, right, if I press enter, Python automatically creates these two spaces for me. Right? I didn't even put the two spaces there. I just press enter. Python automatically created the two spaces for me. And what these two spaces are is known as indentation. So these two spaces are known as indentation. And any lines of code that has indentation in front of it will be considered to be part of this if block. Right? So this line 2, we're said when we write a colon like this, we're said to be starting an if block. We're said to be starting an if block. And whatever lines of code that has a conditional is inside this if block. So if I say condition is true, like this, right? And whatever other lines of code, let's say I say meow, 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 right? The lines 3 and 4, because by the virtue of the fact, right, that they have these two spaces in front of it, you can induce the two spaces by putting space, space, or you can, if you can press tab, right? A single tab will also do it. If any lines of code that has these two spaces is considered part of the if block. And in this case, the lines 3 and 4, part of the conditional, is only going to be executed if the condition is true. Right? In this case, the condition is true. So I print run, I do see, in fact, condition is true, line 3 is executed, meow, 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 right? Line 4 is executed. Right? But if let's say the condition was false, I change this to false, then I see nothing outputted, right? Nothing is outputted because what has Python done? It went to line 1, set condition, it creates a condition variable, a variable called condition, and set it equals to the value of false. Then line 2, condition was false, so it ignores line 3 and 4. Right? Lines 3 and 4 is only executed if the condition inside this if statement is true. Okay, so if the condition is true, line 3 and 4 executed, right? Otherwise, it's not. Then I can also put this else statement over here. And if I put an else statement, I put condition is false, and over here I print woof, 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 right? Then if the condition is true, lines 3 and 4 is executed, right? Because of this conditional, if condition, checks whether the condition is true or not. In this case, it's true, so it executes lines 3 and 4. But if I change the condition to be false, right, then lines 3 and 4 is not executed, as we've seen previously, but lines 6 and 7 will be executed because they are under this else block. Right? So else with a colon, right, then whatever there's indentation is considered to be part of the else block. So in other words, conditionals provide you a way of branching your logical flow of code, right? We have covered the building block of variables. This is a new building block right now called conditionals. And what conditionals allow you to do is choose which lines you want to execute under what conditions, right? So, yeah, so before conditionals existed, Python was like, okay, I'll just run every single line, right? Since that's what I do, right? But now that we have conditionals, you can tell Python to be selective about which lines of code they want to run, right? And yeah, and to tell Python to do that, you write this if and round brackets, and inside this you put a conditional and the colon, and after the colon, whatever code is as a two spaces over here, which is what we call indentation. Whatever code that is the indentation is part of the if block. And then you write else and a colon that indicates the end of the if block, right? And whatever code that has an indentation after the else colon will be considered part of the else block. And whatever code that's outside over here, right? Print done. Whatever code that's outside, right, that doesn't have the indentation is neither part of the if block nor the else block, right? It's just outside the conditional. So if I run this, you see, I see condition is false. Line 6 is run, line 7 is run, and then line 8 is run, right? If I change this condition to true, line 3 is run, line 3 is run, line 4 is run, and line 8 is run. Can you guys see the logical flow, right? Python will either go line 1, Python will either go line 1, line 3, line 4, line 8, right? 1, 3, 4, 8, 1, 3, 4, 8, if the condition is true, or if the condition is false, it'll go 1, 6, 7, 8, right? 1, 6, 7, 8. So, okay, so question, out of curiosity, does this only work if the condition is a Boolean value? In Python, yes, condition needs to be a Boolean value. If I have, okay, so if I condition equals to 5, that's a very good question actually. If I condition equals to 5 and I run this, you're gonna get, okay, in this case, let me see, condition is true. If I put 0, it's gonna be false, I believe. Okay, so okay, in Python, right? Okay, I'm a bit hesitant to say this Okay, so technically speaking, to answer your question, technically speaking, does this only work? It works when your condition is not a Boolean also, right? In this case, I've just as an example of condition equals to 5, and in this case, it's interpreted as true, right? But I'm a bit hesitant to say, um, I'm gonna caution you guys to say that try to avoid this type of code, because um while this code works, right? Essentially, you're saying if 5, and logically speaking, if 5 doesn't really make a lot of sense. It's more like a shortcut, right? Usually what this is useful for is um when coders write something like functions, right? Then the function would return a number. Like sometimes they might return 0, 1, and 2, and 3. So this is essentially, you write if 5. This is more like a shorthand for if you do some mathematical calculation up here. Let's say you do condition equals to 5 plus 6 minus 11, some mathematical calculation, and then you say if condition. Usually what programmers mean, the reason why this is the reason why you can write if 5, or if 1, if 2, if 3, or if 0, if some number, right? The reason why you can do this is because it exists as a coding shortcut for it's a shortcut lah for more experienced programmers. But even as I write my own code, I'm very hesitant to say if 5, right? I prefer to, if you want to compare something with 0, I encourage you guys to always write if x double equals to 0, right? Don't just write if x uh equals to 0. It's a bit risky, right? So yeah, so to answer your question, out of curiosity, does this work only if the condition is Boolean variable? No, it also works if it's a number, right? I'm not sure about string. Let's try. Okay, it also works if it's a string. And if it's an empty string, it's actually interpreted as false. Yeah. So to answer your question, no. But try to avoid this practice, because it's a shortcut, and if you're not careful, you might it's better to be very aware of what type your variables is right now, right? So it's a shortcut, and it's a bit of a dangerous shortcut if you're not conceptually clear on what's going on. Okay, so for now, yeah, that's a very good question, by the way. Very good question. Keep the good questions coming. And so for now, right, whenever you write if some condition inside, I want you guys to always make sure that the inside here is true or false, right? Don't put an integer inside here. Don't put a string inside here. Inside here, I want you guys to put true or false, because logically speaking, if true, do something. If false, do something, right? Yeah, that is a very clear cut. Okay, very good question anyway. So yeah, so conditionals allow you to branch lines of code. They allow you to do splits in the logic, and that's cool and awesome, right? So awesome. So in the next example, okay, so this is just saying line 3 is run, line 5 is not run. Okay, so in the next example, I will use condition equals to false, and I think you guys should probably know the answer to this. Yeah, for the people who just joined, you can join the current Kahoot right now. Yeah, you can join the current Kahoot right now. So how it works is, I'm not sure if you can see the previous chat, but I'll just copy paste in the Replit link again. So for the people who just joined, you can open this Replit link, and if you open it, you will see something like that, right? And what we're doing right now is writing code on the left-hand side. We're copying the code from the Kahoot into the left-hand side, and we're pressing run. And we press run, right? You just read the output and answer the Kahoot. So yeah, so that's how this Kahoot works. Okay, great. So some errors. So if condition is false, right? Condition is now false. If false means 3 is not run. Line 3 is not run. Okay, because the condition is false. And then it runs the else statement, which executes line 5, which prints condition is false. That's why the answer is green. Any questions? Okay, so yeah, line 3 is not run, line 5 is run because the condition is false. Okay, so you can this picture just shows you what you can do with conditions a bit more, right? And I just want to say that Python literally goes to line, you can think of Python as literally going to line 1, line 2, and executing the lines sequentially, meaning that it's literally like this little guy that goes line by line, reads line by line, and executes each line by line. What I mean by this is, if I have, let's take a look at this code snippet, right? So our condition equals to true, x equals to 2. Create a variable x with a value of 2. So if is condition true? Yes, condition is true. So executes lines 4 to 7. The print condition is true, we see that appear on the screen. Line 5, more code here, we see that on the screen also. Line 6, x equals to 3, right? And then that doesn't print anything yet, right? Line 7, print x, I see 3 appear, right? And then it ignores lines 9 to 11, right? Completely ignores them. Okay, and in the next one, if I set condition to false, then lines 4 to 7 is ignored. And lines 9 to 11, sorry, lines 4 to 7 is ignored. Lines 4 to 7 is ignored. Lines 9 to 11 is executed because the condition is false. Right? In this case, you see I printed, so lines 9, print condition is false, you see that appear. Line 10, other stuff here, we see that appear also. Line 11, print x minus 2. In this case, what is the value of x? The value of x is 2, right? Because remember, line 6 was ignored, completely ignored. Line 6 was not executed because the condition is false. So line 11, 2 minus 2 is 0. So I just want to emphasize over here that you may see lines of code appear, right, in Python, right? Things like line 6. Line 6 appears. Line 6 sets the new value of x to be 3, right? But not every, if conditionals, not every line is executed. Some lines of the code is ignored, right? If every line was executed, then line 11 would be 1 instead of 0, right? But I just want to emphasize over here that just because you see code in Python doesn't necessarily mean it's executed, right? Remember, Python goes sequentially, and based on these conditionals, it will branch out. So lines 4 to 7 completely ignored because condition is false. So yeah, just this example emphasizes that the concept of branching using a variable, right? So now we're putting the two Lego blocks together and we're forming this amazing composite program. Right? So that's our first slightly bigger program. Okay. Okay, so now your conditionals can be comparisons also, right? So if I can invite you guys to either type it out in the chat, not type it in the chat, type out in the Replit, or you can use your eyes and think. So x equals to 5, I create a variable x and I set it equals to value of 5. And then if x is greater than 6, right, I print wolf, I am dog. Else I print meow, I am cat. So if you're not sure, feel free to type it out in the Replit. We got a lot of time. If you have already done it, right, feel free to change the value of, okay, awesome. So all of you guys get it correct. I don't think much explanation needs to be done here, right? X is 5, 5 greater than 6 is a false statement. So lines 3 is ignored and lines 5 is executed. Everyone clear? I think since all of you guys got it correct, I probably don't need to spend too much time on this. If you want me to elaborate, feel free to tell me to do so. So condition is false, only line 5 executed. Yeah. Okay, so in summary, conditionals allow us to execute certain lines depending on some conditionals is true or not, right? And this is cool, right? So in the next one, there's one more conditionals Kahoot, right? And then yeah, there's one more conditionals Kahoot. Good job, guys. Okay, awesome. Good job to these people and good job to everyone for completing conditionals 1. Okay, so conditionals 2. Conditionals 2. Yay. Okay. So can I invite you guys to join the conditionals 2 Kahoot? Right? It's basically logically. Oh, that's a very short game pin. Okay, logically it's basically the same thing. Just a bit more concepts. You see, once you get the logical concepts, which isn't too hard, right? You realize that coding is just very logical, and the challenging part is actually not the building blocks, but it's piecing together the building blocks to achieve what you want, right? And that's what people go to university for. Oh wow, we have so many people. Okay, so 10 more seconds to join. If you need more time, drop your name in the chat. Okay, cool. Beginning now. Okay. Okay, so second conditionals. Okay, so feel free to type it in the console, in your replit again. Okay, this is a bit longer line of code. I create a variable called x, and I set it equals to input, which asks the user for an input. I put favorite animal colon. Right. So I'm going to use these few animal examples. Right. You can type out the code so that if you're not sure, you can type out the code so that you can, because this example is going to appear quite a lot. Yeah, and it's also good to practice typing out these funny symbols, right? So right now, I think when you first start, everyone will take some time to type out the round bracket. Sometimes you're like looking for it and then whatnot, and looking for the colon, because these are things you don't use a lot. And things like tab, spacing, they matter also, right? So you need to be careful. Line 5 has 2 spacing, line 6 has 4 spacing, line 7 has 2 spacing, line 8 has 4 spacing. That tells you that lines 5 to 8 are inside this else block. Okay, so and line 6 is inside this if x equals to dot block, right? So line 6 is inside the lines 5 conditional. So you can see in this case, we've talked about conditionals, but in this case, it's a more complicated example where you can have conditionals inside conditionals, right? Within line 3 is inside the if block. Lines 5 to 8 is inside the else block. But lines 5 to 6 itself is a if block and else block. Right? So it's like if within if. It's like inception, right? Yeah, you have conditionals within conditionals within conditionals. Yeah, and it can get quite messy. But no worries, right? This example is just to yeah, this is just an example. Later I'll tell you how to shorten your code. Okay. Okay, so if you guys need more time, or can I give you guys until 100 seconds? So around 15 more seconds. Okay, awesome. So 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 if you got an error, I think chances are that you probably mistyped a spacing somewhere. And if you want, you can drop me a private Zoom chat, right? Private Zoom message, so I can tell you which spacing you missed out on, right? So I think it might be a typing error. So okay, so the point is, I input a cat, right? I input a cat over here. So x line 2's conditional is true, right? Cat equals to cat. So line 3 was executed. Okay. And line 3 was run, and everything else, right? Everything inside the else block is not run because the condition was true. So everything else is ignored. Okay, so what if I input same code, but I input dog instead? Right, so there's going to be three of such examples. One of it is done already, but these 3 examples just go to show. I just wanted to bring you guys through the flow of conditionals, right? If in a nested way. Okay, awesome. All you guys got it correct, right? So the flow of logic is I input a dog equals to cat is false. So line 3 is not run. Right? Line 2 conditional is false, so line 3 is not run. So line 5 to 8 is run. But line 5 to 8 itself is a conditional. So line 5 is conditional, dog equals dog is true, so line 6 is run. Right? And line 6 in this case prints wolf. And since the conditional in line 5 was true, it ignores line 7. And it ignores line 8, the else block. Okay. And so whenever you think of conditionals, go sequentially, pretend you are Python, pretend you are a computer, pretend you're comparing by comparing, pretend you're doing this procedure, very systematic, right? Very simple. Okay. So how I'm reasoning it out is how you should probably think about it too. Okay. By going line by line, right? If you look at a whole chunk of code, it might be a bit daunting. But if you go line by line and reason it line by line, it will be a lot clearer what's going on. Okay, so if I input owl instead now, if I input owl with the same code, right, what is executed? Awesome. By is the answer. Okay, and the answer is that okay, so in a classroom setting, usually I'll get one of the students come up and explain the conditionals like I would, but I know interacting on Zoom is a bit hard, so I'm just gonna do it. Okay, so owl, x equals to owl, owl equals cat is false, line 3 is ignored, so lines 5 to 6 run, owl equals to dog is false, line 6 is ignored, so else block, line 8 is run. So we see by appear. Okay, simple enough. Okay, awesome. So, okay, so if the thing is that if I want to add even more animals, if I account for more animals that the user might input, then you can see that I need to put even more conditionals within the conditionals, right? You see, every time I have else, the number of indentation, the number of spacing in front increases by 1. So eventually I'm going to get a diagonal. The code is going to look very diagonal, right? And that's not very pretty on the eyes, right? That's not very elegant. So Python has this shortcut that allows you to do chaining of conditionals. This is known as chaining conditionals because they're putting conditional within conditionals. But there's this shortcut that lets you do chaining of conditionals using this elif instead. So remember that this is going sequentially. So it tries to, Python evaluates the line 2 conditional first, right? Evaluates line 2 first. If it's true, it runs line 3 and everything else is ignored. Lines 4 to 11 all ignored, right? But if line 2's conditional is false, then it goes to the next one and tries the next one. So it looks at 4. If 4 is true, then everything after that is ignored, right? But if 4 is false, then it tries the next conditional. So you can see that it's like, that's what else if essentially is. Elif is short for else if, right? And this else if is like else if, right? It's like trying one by one, right? And the moment it hits something true, it ignores the rest because it doesn't hit the else for the rest already. Clear? Okay, so this is just a shorthand. But it's a very useful shorthand, right? Very, very useful shortcut. Okay, so another example, right? Illustrating something known as the N keyword. Okay, so my gender is male and my age is 19, right? I made these slides when I was 19, so that's why. So if gender equals to male, I'm comparing the gender variable with the string male, and my if it execute line 4 and 5 if that's true, right? So I'll let you guys think about this for a while. The reason is because at the time of writing of these slides, I was 19 and I was male. Right? Okay, great. So I think you guys get the idea, right? Both conditionals are true. So line 3 conditional is true. Okay, let me see. Let me see if there's a like lines, both conditional line 3 and 4 are true, right? So line 5 is executed. Clear? Okay, but you can compress it into a single conditional by using the and keyword. So you see that line just now line 5 was only just now the print high was only executed if both conditions were true, correct? And we wrote two if statements to do that, and that caused indentation to appear twice, right? But if I want to compress it into one if statement, I can use the and conditional, and so I can have if gender equals to male and age equals 19, and this combined conditional, this composite conditional is only true if individually each of the conditionals are true, right? So this and combines two conditionals into a big conditional, and the big conditional is only true if the individual conditionals are true. Right? Simple enough. It's like saying it's basically like English, and is a logical and, right? And so if I print a bunch of, if I print true and true, I get true. Print true and false, I get false. So you can see that these 4 lines is what we call a truth table. What I call a truth table, right? In the sense that I'm trying every single combination of true and false for both sides of the n. And you can see that the output is only true if both conditionals are true, if it's true and true. Okay, so that's just the and keyword. Now the next one, the next keyword is the or keyword. Okay, so that's oh, okay, sorry. Before that, I have this quick quiz, right, to make sure you understand the and keyword. So I created a variable called x equals to 5. I created a variable called x and I said it equals the value of 5. And in this case, I'm trying to evaluate whether x is less than 8 and x is less than 1. Okay, so most of you guys, a few fluctuations here and there, statistical fluctuations. Okay, so if you run it, you get false, right? I think, okay, I'm just gonna run it because x equals to 5, so you guys can see x less than 8 and x less than 1, I get false. Okay, I get false is the answer. And the reason is because x is less than 8 is true, but x is less than 1 is false. Okay, so if I print them individually, you can see that line 2, x less than 8 is a true statement. Line 3, second output, x less than 1 is a false statement. Combined together, true and false gives me false. Okay, remember, true. These two is only true if the combined conditional is only true if both individual conditionals are true. Okay, so that's the and conditional. How about the or conditional? Okay, wait, I think before that, oh yeah, now we're moving on to the or conditional. So quite a big line of code, but the output is simple, right? It's just whether there is meow wolf or whether there is no meow wolf. Okay, so if you write this line as code, line 3 and 4, you can copy paste it to speed it up a little bit. Okay, great. All you guys got it correct. So the case I want to emphasize over here is that okay, so which one was the one that was executed? 5, x is 5, line 2 conditional is false, lines 5 conditional is false, lines 8 conditional is true. So lines 10, 9 and 10 are run. But can you see that line 3 and 4, lines 6 and 7, and line 9 and 10 are all equal, right? They're the same lines of code. And if they're the same lines of code, and if there's if else, if elif like this, that means that any one of these conditionals, as long as one of them are true, right? As long as one of them are true, the same lines of code executed. I mean the same, as long as one of them are true, the content, right? The content of the code that I'm executing is the same. And that means that motivates us to compress these conditionals into something known as a or conditional. So right now I'm saying if x is less than 3, or x is greater than 10, or x is equal to 5, then I run lines 3 and 4. Right, in this case, you see, I only print meow and print wolf. The code, I only write it once, right? And I've compressed the long list of code into a single conditional, right? Clear? So that's what the or statement is used for, right? It's used to, just like the and statement is used to combine two composite conditionals into a bigger conditional. The or statement is used to combine two composite conditionals into a bigger conditional. And in this case, the combined conditional is true if the individual conditionals, if either one of them are true, as long as one of them are true, right? So this, just like how in the previous slide, I show you guys the truth table for it. I want you guys to try or either write out the code or guess what is the truth table for this. So I have true or true, is that true or not? Right? And false or true, is that true or not? True or false, is that true or not? And false or false, is that true or not? So this is known as the truth table, where I evaluate all the possible individual conditionals of this or statement. Okay, so yeah, it might be quite a bit to type out. Okay, do note of the capitalization, right? The capitalization must be correct also. Okay, so a bit of mixed answers here, right? The answer is actually true, 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 false. So you can see that I see quite a few of you answered true, false, 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 right? And that would be the case for the and conditional. Right? In this case, I'm using the or conditional, which means that as long as one, right, if I have A or B, as long as A or B, as the name suggests, as long as A is true or B is true, right, the entire thing is true. Right? As long as one of them are true, they carry the team, right? And the combined conditional is true. So yeah, so this is the truth table for the or keyword. Which, so in other words, the and or, they help you combine small conditionals into a bigger conditional. Okay, and using that you can do certain logical stuff. Right? I think the last example is Okay, so this example is just to emphasize the concept of all conditional. So if I x equals to input, how's your day? And the user inputs good, right? So x is good. X is the string good. X stores the value, the text value good. And I compare x and good. Right? I compare x versus good, or x equals awesome, right? Is x good or is x awesome? If either one of them is true, I print that's nice to hear. Otherwise, I print or hope tomorrow's better. So question, what is the answer? Right? I think I'll give you guys time until maybe 170. Right. 170 seconds. Since there's 7 answers in already. Okay, awesome. So I will get it. Okay, so in this case, the which conditional is the true one is the first one, right? X equals good is true. X equals to awesome is false, but it's okay because the first one was true already and it's all conditional, meaning that as long as one of them are true, the combined conditional is true. So line 2 combined conditional is true, and hence line 3 is executed. Everyone clear? Okay, so yeah, so that's conditionals. And the last one, I believe, is a password. Yeah, okay, so password. So if x equals a secret, door whooshes open. Otherwise, print the wrong password. Okay, so feel free to type it out. I'll give you guys time until maybe 170 or 150. If you guys need more time, just let me know in the chat. Okay, awesome. Everybody got it? Right, simple enough. The x equals a secret. X stores the value of x stores secret as a string. And in this case, secret equals secret, so line 3 is executed. But question, what if I wanted to swap lines 3 and 5? Right? What can I do? So why I might want to do this is because maybe, right, usually this goes on to the idea of implementation. Just now I said there's many correct pieces of code for the same behavior, but some of them might be more elegant than the others, right? And in this case, we might want to swap 3 and 5 because it'd be more elegant. And let me explain why. So if let's say you got a password, right? Let's say Facebook or let's say Instagram, you put in the correct password, then you load a bunch of stuff, right? You have a bunch of code doing a lot more things, loading your friend's feed and your feed and whatever, loading your account, profile picture, things like that. Basically, if you got a correct password, you want to do a lot more code, right? Line 3 is currently we just have line 3 alone, but if in general, if you get a correct password, your lines of code will be a lot more than if you got the wrong password. If you got the wrong password, you're just telling the user try again, right? But if you've got a correct password, you'll be having thousands of lines of code to handle that kind of logic. And in this case, if you have imagine if you're writing this code and then you're saying if x equals a secret, then you have thousands of codes, thousands of lines of code. And then at the end of the thousands of lines of code where you need to scroll all the way down, at the very end, right, you have else print wrong password. Can you see that? Can you see that it's a bit jarring in the sense that you have some code, then you have a huge chunk of code, and at the very bottom you have the code that handles the wrong password case. It'll be much nicer, right? If you have the huge chunk of code, you can rearrange the huge line 3 and 5 swap so that your huge thousands of lines of code, right, is at the bottom instead, because that way at the very bottom you can add on more stuff more easily, right? If you want to add more logic to it, you can easily add it to the bottom. You don't need to scroll down all the way and then minus 2 lines to avoid the wrong password case. So this is a bit on the notion of elegance. If you want to write elegant code, you might want to swap lines 3 and 5, right? And if you want to swap lines 3 and 5, how do you do it? You can use something known as the not keyword, meaning that if not x equals a secret, right? Meaning this x equals a secret is a conditional, is a boolean, right? And in the not keyword will invert the answer, right? So you can see I swap lines 3 and 5 and I put this not keyword over here. Logically, it's the same thing, right? Logically, it behaves the same way. Okay, so what means this not keyword, right? How does it behave? It flips the value of the boolean. So if I print not true and I print not false, maybe you guys can try the answer. You can either type it out, it's quite short, or you can try to think. So that's not will help you invert the conditional. it would really be a lot nicer if it was a physical lesson and then you guys can try the practices, because it's quite fun to write down your own conditionals, right? So right now you're just copying code from the Kahoot, which is maybe a not so fun. But if you're writing your own code, where you're writing your own program logic, you're creating your own program. You're creating it's like creating a baby, right? You're creating it's your own creation, right? You're creating you're creating your own program. You put in whatever logic you want. You get control over how your program works. That's what some people like about programming, I guess. It's the fun of piecing together these Lego bricks. Okay, I'm just gonna do until 150 seconds, maybe. Okay. I'm gonna press skip in the interest of time. Is that okay? Okay, so yeah, okay, so in that case, I get false and true. Okay, so the not keyword simply inverts the value of simply inverts the value. Okay, I realized that I probably should not have pressed skip, because that that would not give you guys feedback on whether that's correct or not. Okay, anyway, point noted. Okay, so okay, this one you guys can try typing it out, because it's something that you probably might not be able to infer. Middle East, so try typing it out, and this is where I say just now we talk about the string type of variable, right? String is text. We also talk about integer type of variable, right? Integer is numbers, right? Float is actually decimals. So just now we deal with whole numbers. That's why we saw integer as our variable, right? Like 5, 4, these are whole numbers. So the variable type is integer. But if you do like 3.14, or you do like pi, right? Or uh 1.234, right? Decimals would be of type float. And now this one would be what would this be? Okay, so you print type true. This is known as I think 11 answers, and it's not okay. Awesome. Okay, so you're gonna get boolean. Okay, so the reason is not string, right? I just want to emphasize this, right? So just now I said that where x equals to true, right? If I print type of x, if I put quotes around it, I'm gonna get string. Right? I put quotes around it, I'm gonna get string. If I don't put quotes around it, is going to be boolean. Okay, it's distinct. It's very different. So true as without quotes and true with quotes different. Question if okay, and one thing is that true as a boolean must be with capital T. Right? If you try to put true with a small t, it's going to be error. And in this case, the type of error they're actually telling us is that we're looking for a variable called true, right? Because true, it doesn't have capital T. So Python is thinking, oh, true sounds like a variable name to me, right? Because and they color in white to hint to us that looking for a variable called true. And they say name true is not defined. The variable true is not defined. So just to emphasize that true with a capital T is different from true with a small t, right? And true with quotes is different from true without quotes. Okay, so yeah, so that's okay. So print type is true, and okay, so that so in summary, right, here's what we call a truth table. We learn how to compare numbers using the greater than sign, less than sign. If you want to do greater than equals to, it's actually this thing, or less than equals to actually this thing, right? It's just this is just the way that Python likes it, right? There's no other symbol. Yeah. And you know do equals to is double equals, right? Remember the difference. Remember the difference between single equals and double equals. Right? Single equals is for assignment of a variable on the left hand side to a new value on the right hand side, right? And the double equals is a comparison of the value on the left hand side with the value of the right hand side. not equals, you can either use a not keyword or you can use exclamation mark equals. So yeah, then truth table, and keyword, or keyword, not keyword, right? So and or, they combine two smaller conditionals into a bigger conditional, right? Based on these properties, based on these truth table values, not keyword inverts the conditional. Okay. And yeah, so if not, very good job, because you guys just completed your second logical building block, right? So okay, so in the, let me think. I do have a functions Kahoot. Let me think. Okay, I'll get you guys to do the functions Kahoot, and we should be able to complete it in time. Yeah, let's do the functions Kahoot. Let me just find it. Okay, so any questions? Okay, so if not, congrats to everyone. Everyone's a winner. And here's the functions Kahoot. So as you guys are streaming into the Kahoot, let me just talk a bit about what functions are. Okay, so I'll send it to the Zoom chat. As you guys are streaming in, let me just talk a bit about what functions are. So think of your morning routine. When you wake up in the morning, right, what do you do? Maybe the first thing you do is turn off your alarm, right? Then after that, you go to the toilet, then you brush your teeth, and then you change your clothes, right? These are all known as routines, right? Every morning you do the same routine over and over again. And each of these routines, let's say brushing your teeth itself is a routine also. Brushing your teeth consists of many steps, right? It consists of let me see, 7, 8, 9. I'll just wait for maybe 30 more seconds for explaining the motivation for functions. So you can think of every morning, you have some morning routine, and your morning routine, like brushing your teeth, they consist of sub-routines, meaning that brushing your teeth itself consists of many, many smaller steps. Okay, so you can see that your routine consists of subroutines, and your subroutines consist of subroutines, and your subroutines consist of subroutines, right? Ultimately, your entire morning routine, your entire morning so-called program, your morning script consists of many, many subroutines. And so functions help you achieve that kind of behavior. Okay, so let's begin. Okay, so functions. Okay, so I'll invite you guys to type it out, right? This is a new thing. We see the DEF keyword is a new keyword. I'll talk about what it is later. But for now, if you're not sure, I encourage you to type it out, because typing out really helps you understand better. Typing out really helps you internalize the syntax a bit, right? If you want to be serious about programming, right, just understanding the concepts, that's just the first step. I would say that most of the learning comes when you actually try to write your own programs, which which in the physical lesson we'll be able to do in the Kahoot. We'll be able to do in the Repli exercises where you write your own code. But for this Kahoot, the best I can achieve is to let you copy down the code, because I'm unable to evaluate. I'm unable to see the code that you write, and it's also a bit harder to explain where you went wrong over online setting, right? But yeah, so this is the best we can do for now, right, using Kahoot. So I encourage you guys to copy it down. At least that will get you familiar with the syntax. So remember, line 2, just to point out, line 2, there's 2 spaces, just like how inside the if statement, there's 2 spaces. Yeah, just like how inside the if block or the else block, we have 2 spaces, and the 2 spaces indicate that it's indentation. And then whenever we have indentation, it tells us that a certain part of the code is within another block of code, right? So in this case, whenever you see a colon in Python, right, that indicates the start of what we call a code block. And this code block will consist of a chunk of code that is inside this code block. So if I roughly explain what's going on now, we're actually defining a function called say hi. And this case, the function say hi contains line 2, right? So you say that, okay, awesome. Okay, so when I do this one is a bit good it's better to type it out. So I'm going to type it out, even though you guys already did it. But what I did over here, I just defined a function. I just defined a function called say hi. So when I want to define a function with a function name, I write def and then space and then the function name I want. I can name it anything I want. I can call it meow. In this case, I call it say hi. Okay. And then I write round brackets. Round brackets is important when you're defining a function. It's just the way it is. The round brackets actually contain the round brackets is actually eventually going to contain something we call parameters. But for now, the function takes no parameters, so there's nothing in the round brackets. Okay, and I write colon, and the moment I type colon, you see if I press enter, there's two spaces that's automatically created for me. That's known as indentation. And then inside this indentation indicates that whatever I write here is inside the function. That's inside the block of code. Inside is a block of code that's inside the function. So I write print hi inside the function, and now line two, okay, this autocomplete thing is a bit annoying, but line two is now inside the say hi function. That's what we say, right? This two lines say that line two is inside the say hi function, right? And okay, so question is, if I write other lines of code, let's say I write by, I print by, line three, because there's this indentation, is also inside the say hi function, right? But if I go beyond that, if I have, let's say line four, and let's say line four, I write print meow, right? Line four is not inside the function because it doesn't have the two spaces at the beginning, right? It doesn't have the two spaces at the beginning. And whatever is not, doesn't have two spaces is not inside the function anymore. And subsequent lines, whatever subsequent lines after that is not inside the function also. So, yeah, so in this case, okay, to copy the example, I write say hi like this, I delete line three, and if I press run, I get hi. Okay, so that's why the output is hi. So question now, what is going on over here? When I define a function, say hi, it defines a routine, it defines a subroutine, right? And I'm telling Python that line two is inside this say hi subroutine, this say hi function. And when I call the function, it'll jump into the function and execute whatever is inside the function. Okay, so more on this, if let's say I write print by over here, then when I execute say hi, right, execute say hi, the order of execution is actually line one, right? Line one defines the function and tells Python that lines 2 and 3 are inside the function, but it does not execute lines 2 and 3 yet, right? Goes line 4, only when I run line 5. Line 5 calls the function, and how I call the function is I write the function's name, right? When you want to call somebody, you call them by their name, right? When you call by a name, if you want to call a function, you need to put your function name like this and then put round brackets after that, right? And you do this, then when Python reads line 5, it will jump into the function and execute lines 2 and 3. Okay, so what this means is that I want to emphasize a little bit of a tricky scenario over here. Let's say I print by the line 4 is outside the function. Right? So question now, will I see hi by or will I see by hi? Okay, so take 3 seconds to think about it. Will I see hi by or will I see by hi? Okay, so think about it, log in your answer in your brain. I press run, you see by hi. Why is that so? Right? The reason this is so is because even though in the lines of code, I see line 2 appear before line 4, right? Even though I see line 2 appear before line 4, but line 2 is inside the function say hi. And the function isn't executed. The code inside the function isn't executed until I call the function. In other words, if I remove line 5, right, the only output I'm ever going to see is actually just by, right? If I remove line 5 and just execute this, you see, even though I print hi like that, because it's inside the function is never called, I'm only going to see line 4 get executed, right? So when I define a function, you can think of it like it's sleeping, right? If I define a function and I write some code that's inside the function, Python's like, okay, right? You have defined this subroutine, right? But I'm not going to execute this subroutine until you call this function and wake it up, right? And the moment you call say hi function with round brackets, you're waking up the function. You're like, hello, say hi function. You there? Wake up. And then when you call the function, it wakes up and it executes all the code inside the function and then it goes back to sleep, right? So if you don't call the function and you don't wake it up, right, it's not going to execute the code inside the function, right? So if I do this, you just see by because only line 4 is executed. Line 2 is not executed. Okay, but if I do say hi after I print after line 4, I'm good. Python is actually going to go line 1, defining the function, right? Then it's going to go to line 4. It's going to print by. Then it's going to go to line 5. And what does line 5 do? Line 5 jumps into the function and executes line 2. So the order of execution is actually 1, right? That defines the function. Then it's actually 3, or 3 is blank, right? 3, 4, 5. And after it goes to 5, it actually goes back into the function, back into 2, and then continue onto 6. Okay, so if I do, let's say, print after, do print before, say hi, and print after, you can see that the order of execution is actually line 1 defining the function, line 4, line 5, and when I run line 5, it jumps into the function which executes line 2, right? And then after the function finishes executing, it goes back to where it was, continues with line 6. So I print this. If I press run, you're going to see the output is before, then hi, and then after. Even though, as I say again, even though the code, in terms of the code, the print statements is hi comes first, then before, then after. But we see when we actually execute the code, when we actually run the code, line 4 is executed first, right? Because we see before, and then line 5 prints goes to line 2, hi, and after. Okay, so everyone clear on what's going on? So you can see the functions. Just now in conditionals, we had some amount of control over where the lines of code we want to execute, right? We can say, when we talk about conditionals, right, we can branch the code, say, oh, Python, if this condition is true, run this chunk of code. Else, run this chunk of code. But now with functions, we have even more power, right? Now with functions, we can even say, wait, Python, runs line 4, run line 4. Python's like, okay, run line 4. Then you tell Python to run line 5. And because you define a function called say hi with some code inside the function like this, Python's like, okay, I'll jump right there right now. And it will jump into the function. And now your order of execution is even more, even more, you can control where the code jumps, right? To, and you can jump to here, jump to there, jump to here, jump to there using functions. So you have even wilder, I'll say wilder behavior. But if you control it well, it's actually really well controlled, right? So these are known as subroutines, where now Python can go line 4, line 5, line 2, right? Line 6, right? And if I call the function a few more times, right, what it'll look like is, let's say I call it 3 times, it'll look like this. So it'll be line 4, line 5, line 2, line 6, line 2, line 7, line 2, line 8. Right? So you can see that using functions, I can make Python go jump here, jump there, jump here, jump there, jump here, jump there, right? Yeah, so whenever I call a function, it jumps into the function, executes all the code that's inside the function, and then it continues with the rest of the code. Okay, everyone clear? And this is quite powerful, right? So what's the point of functions? Okay, so before that, before I talk about the point of functions, I've talked for quite long already, so I'll get you guys to do some coding. Okay, so if I call the function twice, what will I see? Okay, so because Kahoot doesn't allow me to put new lines as inputs, I just put a bracket new line like that to indicate there's a new line. Right? I hope that's understood. So question is, will I see a single high, which is the blue color, or will I see 2 highs, which is the red color, or will I see no output, which is the yellow color, or would it be an error, which is the green color? Okay, so if you have written the code, just add one more line of say hi, and that would be good. Okay, awesome. Okay, very, very good. Okay, so I call the function twice, hence I see 2 highs appear. Okay, what if I don't call the function at all? Right, so the next snippet would ask you what happens if I just define the function but I don't call it. Remember what I talked about the function being asleep and not being called, right? Does it ever execute? If you're not sure, feel free to write the lines of code, right? Delete the 2 function calls for say hi and see the output for yourself. Right, so as in my experience, if I just explain it to you like that, Usually it goes into your ear. Maybe you process it a little bit, but it goes out. But the moment you start to edit your own code, right, you start to internalize that. So I hope that through this Kahoot, you can have a chance of editing the code and having the experience yourself, right? Yeah. So the Kahoot is a way to not force lah. It's a way to encourage you to edit your code in a gamified manner so that you have experience in it. Okay. So yeah. So if you do it, then okay. So if I delete all these lines of code, just to show you guys that I press run, you see the answer is no output. Okay, there's no output. So if I clear it and run, no output. And the reason is because I've defined the function say hi. I've defined this routine, but this say hi function is asleep. It doesn't get executed until it is called, until it's woken up. Okay. So any questions? Okay, so what's the point in this? The point in this is that if let's say I print, I can define multiple functions also, by the way. I can define say by, print by, like this, right? And then I can call these two functions. So these are now two different functions. Just like how you can have two variables, you can have two functions also. So I can do print before, and I say hi, and I print after, and maybe in between I say hi and I say bye, and I say hi again. So now I'll see before, hi, bye, hi, right? And the thing is that what's the point of functions is to make your code modular in the sense that if now I wanted to put more things into the function, it's very easy to do so. So let's say I call the function twice. Let's say I say before hi, bye, hi, right? But let's say now instead of just saying hi, I want to give myself a better introduction. I want to say hello in a better, more complete way. So I say hello, my name is Bob, right? Or maybe I can even have two lines of code. So hello, and I print my name is Bob, right? And maybe I can even put an input over here, right? So I can say, okay, so I'll just do this for now. Then you can see that now you see before hello. Wait, sorry, I mistyped it. It's my name is not by name is Bob. Okay, so now I see hello. I now see before line 8, line 9 executes line 2 and 3. Right. So I see hello, my name is Bob. Then it exits the function, goes to execute say bye function. So it executes line 6 bye, then hello, my name is Bob. So the point in this is that if I were to trace the order of execution over here, it'll be line 8, 9, 2, 3, 10, 6, 11, 2, 3, 12. Right. So okay, if what I said confuses you, don't worry, right? If you trace it out yourself, put a bunch of print statements, I think experimenting it yourself really helps a lot. So if I call say hi twice without the bye, I think it's clearer what's going on. You see the hello, my name is Bob appears twice without any bye in between. Okay. And basically the point of this is that I can make my say hi function very, very, very big. Right. Now I can have say hi function doing a lot of code, and you can see, imagine maybe in some of your programs, your function might contain a lot of code, and then every time you want to execute the whole chunk of code just one time, right? Every time you want to execute the whole chunk of code, you just need to call the function once, right? So now instead of, if my lines of code were very, 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 very long, let's say I say my name is Bob 6 times, right? But I just want something like that, right? Every time I want to repeat lines 2 to every time I want to repeat lines 2 to 8, I just need to call say hi function once. Okay, so simple enough, right? Functions allow you to make modules, right? Make modules or make subroutines that you can call again and again and again. Just like how every morning, in the morning when you wake up, you brush your teeth again. Every morning you wake up, you brush your teeth again, right? And at night you call the same function again, right? You brush your teeth again. So yeah, so that's the point of functions. I hope that's clear. Okay, so that's awesome, right? Now we talked about the function. So in general, a function, you can name it anything you want. The naming of the functions follow the naming of the variables. And inside the code, inside the function, you have any code you want, right? The hashtag over here is known as a comment. It's just ignored. Yeah. So if not, okay. So yeah. So all this is just talking about the function. Okay. So now what if I want my function to take in some inputs? Right, this is where it starts to get a bit more interesting also. So this is where we start to see math appear. Right. So if you're not sure, you can type it out. Okay, awesome. You guys all got the correct answer, right? So I believe if I type it out really quickly, so if I define square, it takes in a, okay, so when I write square, right, remember, so far it's just the same thing as just now, but now we put round bracket. Inside the round bracket, we actually type a letter, right? In this case, the letter is a variable name. I put X, put colon. So this variable, this X, is going to store a value that we're going to pass in later. So more on that soon, but I print X times X, right? Now, if I call square function, right? If I try to do call square function without anything inside the round brackets, Python is going to complain. It is missing one argument, right? Basically, Python is telling me you have an X over here, is waiting, you need to put in some input into the square function. And if I put 3 into the square function, I put 3 into the square function, what's going to happen is when Python goes into the function, it's going to set X equals to 3 for this function call. It's going to print X times X, which is 3 times 3. So essentially, the moment I call the function with this parameter 3, right, X is going to be equal to 3, and this code becomes essentially 3 times 3, right, which is 9, which is why we see 9 appear. So if I run this code, we see 9 appear. If I put any other number in here, let's say I put 2, right, then X is going to be equal to 2, and it's going to be 2 times 2, and it's going to be 4, right? And I can call the function multiple times, right, with different values. So I can call 2, 3, 4. I can call one time with 2, one time with 3, one time with 4, right? And each time I do that, it's going to call the function with different values of X. And so the first time I call it, line 4 is going to go, line 4 is going to produce, line 4 is going to go in here and print 2 times 2. Line 5 is going to call the function with X equals to 3 and print 3 times 3. And line 6 is going to call the function with X equals to 4 and print 4 times 4. Everyone clear? Okay, I hope that's clear enough. So that's functions. So the whole point of having functions take in inputs is you can think of functions like a factory, right? It's a subroutine, yes, but it's also like a factory, and your factory takes in inputs, right? Just like math, your function takes in inputs and it produces outputs. So you can have this thing where a function eats some input, and based on the inputs, you can do different things also, right? So you don't just have to print X times X. You can also do things like conditionals inside the function. So you can say inside here, you can say if X is bigger than 10, then you can say print big, right? Something like that. Then now you can see if I execute, if I do this, and over here I put like 20, right? Then it's going to be, the output is going to be 4, 9, 16, and oh, when I pass in 20, when I pass in X equals to 20, 20 is bigger than 10. It's going to print line 3, right? So you see big, and then it's going to go on with your go with your line 4, which print 20 times 20, which is 400. So you can see that you can combine these logical building blocks in certain ways, right? You can put conditionals inside functions. You can put you can create variables that inside the functions. You can have y equals to x plus 2, and then you can say if you can print y times y instead, right? You have all kinds of things like that, and you can piece together these logical building blocks in a certain way that produces some intended behavior, right? Things like calculating the digits of pi, right? If that's what you're interested in, or things like making some login page, right? If that's what you want. Okay. So yeah, so x, I'm passing in x equals 3 as a parameter to the function, and that's what's going on. And now question is, what if I pass in a different parameter? I think you guys will probably expect what's going on already. If I pass in 5 instead of 3, right? Then what is the output going to be? Okay, awesome. So I think you always get the concept, right? Pass in 5, then you print 5 times 5, you get 25. Okay, and I think the last one is just another sanity check where I pass in, oh, okay, no, it's a different function now. So now the function takes in 2 parameters and is separated by commas. Right? So if you're unsure, feel free to type out the code, right? So just like how your functions can take in 1 parameter, they can also take in multiple parameters. In this case, takes in 2 parameters, we call them a and b, right? So what this looks like is multiply a comma b, right? So I'm going to delete these and do this. So I'm not going to delete a square function, right? I'm not going to delete the square function. It's going to be sitting there and it's not going to be called. Okay, so I have multiply colon, right? And inside, once again, code that has the indentation is inside the function. So I print a times b. And if I call multiply with 2 and 3, what's going to happen is multiply 2 and 3. When I press run, it's going to output 6 because a is equals to 2. When I call the function with the parameters 2 and 3, right, a is going to take on the value of 2 and b is going to take on the value of 3 and executes the body of the function, the code inside the function, right? I execute the code inside the function with values of a equals to 2 and b equals to 3. So it's 2 times 3, 6, right? Simple enough. If I do 2 comma 5, right, it's going to be 2 times 5 instead. So it's going to be 10. Okay. And yeah, so once again, inside I can do a bit more. I can print a times a, print b times b, whatever I want, right? Can do anything you want inside the function. This is just a simple example to illustrate your function take in multiple parameters. Questions? Right, so you can see that using this, you can kind of build a simple calculator of sorts. So that's quite a good general exercise. That's quite a good exercise for beginners actually. Yeah. So okay, so any questions? So actually, as a exercise, I'll encourage you guys also to do it. If you guys after these lessons you want to practice writing some of your own code, maybe I encourage you to write your own mini calculator, right? And you can show me the code. I can give you guys some comments about how to improve it. Okay, so question now: what if right now we're just printing stuff to the screen, right? But what if I want to take the result of one function, right? I did some computation inside the function. I want to take the result of one function and put it into the input of another. In other words, I want to export the data from a function. The computation that I did inside a function right now, right? Right now my function is multiply and square. All they do is print it out to the screen, right? But that's quite boring. What if I want to take the data? What if I want to take the 6, I want to take the 36 out of the function and do other stuff with these numbers, right? Maybe I let the function compute some complicated things that like the hundredth digits of pi or something like that I want to export out to do other more interesting things. Then that gives rise to the idea of returning. Okay, so this is a common question because whenever we teach functions, beginners will always ask the question, what is the difference between printing and returning, right? And I hope that using the following example, I can illustrate to you the difference. Okay, so you can try this out. Okay, so let's go through what's going on over here. Right. So I define a function called multiply, and I return instead of printing a times b, I return a times b now. Right. So what's going on when I do this? Okay, question now. If I run this line of code, right? So multiply 2, 3, right? If I run this line of code, just like just now, right? Without the x equals and without the print x, what do I see? I see no output, right? And the reason is because when I go into the function and I put return a times b, essentially it returns 6. And what return 6 does is it essentially replaces this entire function call with the value 6. Right? So now this call to the function is replaced with the value 6. And what that looks like is essentially if I just have a 6 over here, it doesn't print anything to the screen, right? So return doesn't print anything to the screen. There's no output. Return doesn't output anything, right? What return does is it essentially gives a value to this function call, right? So what I mean by that is that if I want to store the output of the function, if I want to store the return value in a variable, I can now do that, right? So if I do x equals to multiply 2, 3, and I print x, I run this, we can see that now I get 6, right? Because essentially what line 4 did was line 4 called the multiply function, and the multiply function, when I return 2 times 3, it returns 6, and that essentially replaces this entire function call with the value 6. So this is essentially saying x equals to 6. And the rest of the code, I think, is quite familiar what's happened. Right? X equals to 6, print x gives you 6. And now, thing is that the difference, you may be wondering, wait, why did I go through all this trouble just to do this? And the answer is that now that I store the value of what the function returned in the variable x, I can do more stuff with it. For example, I can do x equals to x plus 1, right? And now I can change the value of x. Right? I can after I store the output of after I store the calculation that the function performed, right, in the variable x, I can do anything I want with the value with the variable. I can do anything with the calculation that I perform. Right? I can increment by 1. I can do anything I want with the variable that stored the output. And this is something that you cannot do if you just printed it. If I printed it, right, what's going to happen is if I printed it, right, like this, and I try to print x, I'm going to get 6, right? 6 comes from the print statement in 2, but after that, x is going to be, x is none, right? Meaning x has no value. In other words, after I print 6, the moment 6 appears on the screen and the function exits, right, this a times b calculation is lost forever, right? And that might not be what I want, because maybe I want to use this calculation that I perform, which could be more complicated in another example. Right? This is a simple example, but this a times b, I want to save this calculation somewhere. And when you want to save the calculation somewhere, you use the return keyword. And when you use the return keyword, you can save the calculation of a function call inside a variable. Right? So to summarize the difference between return and print is that when you print a times b, right, you're doing the calculation a times b, you're showing it to the screen, the output on the console on the right hand side, and after that, your calculation is not saved, it's gone forever, right? But remember, the whole point of coding is we want to store and manipulate information. So if you want to save the calculation a times b in a variable, right, what you can do is you can return a times b, and outside the function, when you call x equals to multiply 2 times 3, this multiply 2 times 3, it essentially is the value 6. It's as if you're writing line 4 is essentially writing x equals to 6. And this way, you can save the calculation that you have just performed in the function and do other stuff with it. So the next example will show you what this looks like. So this is what I just described so far. The next example would show you what you can do with this, right? So you can chain functions together, right? In other words, I have x equals to multiply 2, 3. That's what we did so far, right? Then if I have another function square that takes in n and returns n times n, I can call x equals to square of x, right? And this essentially squares the value of x, right? And I can do even more stuff with it. So this is what we mean by composing functions. I think if you do JC math, you have quite a lot of bad memories from function composition, right? You need to do you need to substitute in and all this kind of thing. So this is a similar idea over there. You can compose functions. Your calculation in one function doesn't need to be discarded, right? When you do the return keyword, you can return some value, you can save the calculation that you did in the function. Okay, so you can copy this code out, right? And you should be able to see the correct answer. Okay, awesome, right? So all of you guys got it correct. Yeah, okay, so, okay, very good job. Okay, okay, very good job, guys. Okay, so if not, that brings us to the end of the third logical building block, which is functions. Okay, and so for the fourth and fifth one, unfortunately, I do have Kahoot for them, but one is we're running out of time, right? Sorry, it dragged on for 30 more minutes. But another thing is it's a bit harder to explain for loops using Kahoot because I have replicate exercises for loops, but I don't have Kahoot quizzes for loops. So unfortunately, there's a limitation, but it's okay. I'll just briefly try to go through using my replicate. Okay, so okay, let me before that, let me just give me 1 minute to set up something. Okay. Yeah. So any questions? Any questions for what we've covered so far? Okay. So if not, let me begin talking about the. Okay. So let me begin talking about for loops. Okay. So we already covered 3 logical building blocks, which is quite powerful already. Actually, the stuff you can do with these 3 logical building blocks are quite a lot, right? The next one is known as loops. So loops, roughly speaking, they help you repeat a certain chunk of code many times. So just like how just now we did a say hi function, right? And we see that if I print hi inside the function, I can call the say hi function many times, right? I can call the say hi function many times, but there's still some amount of manual work to this in the sense that I need to manually say how many times I want to execute this say hi function. If I want to do it 3 times, I must write this line of code 3 times. If I do it 5 times, I must do it 5 times, right? But there is a systematic way to execute certain lines of code many times, hundreds of times, by writing just very small amount of code. So that's where the power of automation comes in. So you talk about automation and loss of jobs, right? So this is where for loops are to blame for it. Right? If programming didn't have for loops, then job security wouldn't be an issue, right? But if I want to, let's say, print meow total of, let's say, 5 times, right? One way is to copy and paste the code 5 times, but that's inefficient because what if I suddenly want to do it 100 times? Or what if I want to do it a variable number of times? I want to ask the user for how many times they want to do it, how many times they want to print meow, and then I want to print meow that number of times. Then that's where for loops comes in. So to define a for loop, I write for, keyword for, I, in, and I write range, right? So this is just the syntax, just like how we define functions, right? This is similar. And I write the number of times I want to repeat it. In this case, let's say 3. Right? I write colon. And after that, when I press colon, whenever we write colon in Python, there's always going to be these 2 spaces that appears, right? And that tells us that whatever code that's inside this, whatever code is inside this block of code, right? Whenever code there's indentation, these 2 spaces is inside the for loop. So if I clear a console, I press run, you see it appears 3 times, right? And if I just change this number, let's change it to, let's say, 10, right? You'll see that I'll see 10 instances of meow appear, right? I can change it to any number I want. I can even ask the user for a number of times they want to have it. So let's say I say number equals to int input number of times colon, right? And then after that, over here, I put for I in range number. Right? I need to have this int over here. If not, it's going to be a bit problematic. So now the when I run this code, it asks the user for how many times. I put 4, I get 4 meows. Right? I run it again, I put, let's say, 88. Right? I get 88 meows. Right? No, Python has no problem spamming the console with it. I put 1,000, no problem also. 10,000 also no problem. Right? Python is very fast in repeating certain lines of code. You can see that this for loop allows you to do so much with this. It allows you to repeat certain lines of code in a very powerful manner. Okay, and so now, what can I do with this besides printing meow 10,000 times, right? I can also use the index I over here. So okay, unfortunately, I won't be able to go into the full potential of the for loops. There's a lot of very, very rich examples involving the for loops, but I'll just show you guys the surface of it, right? There's a lot of logic you can do with this. But let's say if I want to, question now, what is this I doing here? This I is a counter variable for the number of times the for loop is executed. So as an example, if I print I, right? Let's just do print I, and I'm going to put, let's say, 5 times over here. If I press enter, you see that as promised, right? Whenever you have for I in range num, right? Line 4 is executed a total of num times, right? In this case, num was 5, so line 4 was executed 5 times. That's why we see 5 lines of output, right? And each time, the first time the for loop, the code inside the for loop was executed, right? The first time line 4 was executed, I took on the value of 0. The second time, I took on the value of 1. The third time, I took on the value of 3. Fourth time, 4. And fifth time, 5. So in other words, I is a variable that keeps track of the number of times that the for loop has executed so far, right? That the code inside for loop has executed so far, right? I is a variable that counts the number of times the for loop has run. And what is that useful for, right? That's useful for number one, is useful for generating numbers 0 to some number, right? So for example, if I want to generate all the square numbers, all I need to do is, instead of printing I do print I times I, right? And right now you can see that if I put, let's say I put over here 9, I've just generated all the square numbers up to 8 times 8, right? Or I can even write a more verbal statement. I can write a more lengthy statement saying I times I equals to I times I, like this. And then this way, I can essentially generate all the square numbers with some nice printing. I can say, oh, 0 times 0 is 0, 1 times 1 is, and so on. Okay, and that's the touching of the power of the for loops. I can have, what else can I do with for loops? I can have for loops within for loops. So I can have for j in range num, right? In this case, j needs to be a different variable from I, because I is already used to keep track of the outer for loop. Then the j can keep track of the inner for loop. So it's okay if this part starts to confuse you a little bit, but I just wanted to give you guys a idea of what we can do with for loops. Okay, so I can do I times j equals to I times j, like this. And if I press run, let's say I put 9, right? Then this way, I put 9, I've generated a times table. 0 times 0 is 0. Okay, 0 times anything is 0, so that's not interesting. But I can generate a times table up to 8 times 8, right? And this is just if I put 9 as an input. If I put number equals to 99, I can easily generate the times table up to, okay, it takes a while to output, 98 times 98. So you can see that using for loops, and it really helps you automate certain things. Okay, and so that's just one aspect of for loops. You can use for loops to do some other things. For example, you can put conditionals inside for loops, right? So there's some nice examples involving this, but I think the key idea is just that for loops help you repeat certain lines of code a variable number of times, right? And this is impossible if you didn't have for loops. If you didn't have for loops, you can repeat lines of code manually, but you cannot repeat it variable number of times. In this case, number is something based on the user's input. I can interact with the user. I can change how many times a line of code is run based on the user's input. So yeah, that's just a power of so for loop is another logical building block, and it's quite a big one, in fact. It's quite a powerful one. Okay, and so that's for loops. The last logical building block is actually going to be something we call lists, right? So we have for loops. We have variables. That's very cool. But what if I want to create many variables? What I want to create many variables, and I didn't want to I didn't want to use many different variable names, right? Like for example, if I want to create 100 variables, then I'm going to need to have 100 different variable names, and it's kind of hard to keep track of all that, right? So what I can do is I can create something known as a list. So if let's say I create a list, I call my list. Yeah, actually no, let's just call it capital A. Okay, I create a variable called capital A, right? And I set it equals to this, and I'll create a list of a few variables, right? So okay, let me just say list is essentially many variables. A list is essentially many variables, right? And what that allows you to do is, if let's say I want to create 5 variables, I just put the values of the variables inside, separated by commas. So I say I put 3, 1, 4, 1, 5, like this. And now essentially in one line of code, right? In one line of code and with one variable name, I've essentially created 5 variables. So you may be wondering, wait, but if I call A, which one is it? If I print A, it's going to print out all these numbers. Right? Print A is going to print out 3, 1, 4, 1, 5. But what if I want to access the variables individually? Then this is where the idea of indexing comes in. Just like how you in a class list, right? In a class list, in a name list, you call people by their index number, right? Likewise, in this Python list, you can call each variable, you can access each variable, you can access each variable by calling its index number. In this case, index is starting from index 0, meaning that if I call index 0, I'm going to get the first item. So the reason why we start counting from 0 is due to the fact that for loops also follow the same convention. But in coding, right, you just know that you start indexing from 0, right? Yeah. So sometimes you hear the joke that programmers start counting from 0. That's where it originates from. So I put index 0 is this item 3. I put index 1 is the second variable over here. I put index 2 is this value 4 over here. Okay. So I can also change the value of variable. So I can say A2 equals to 9. So I print A before and after that, right? Then you can see that before line 4, right? So line 2 creates a list with 5 elements inside. Then line 3 prints it, so I just see the first output here. Then line 4 changes the second index, right, which is the third element, which is this number 4, okay, into 9. So 4 becomes 9. And now when I print the list again, it becomes 9. So the power of list is essentially having many variables with just one variable name. So the reason why this is useful is because sometimes you want to create a essentially variable number of variables. Like you want to based on the user's input, you want to have how many variables, and this will allow you to achieve that. Okay, and yeah, so if you can add more variables to this list by doing append, right? Let's say append, if I append 1, then I print A again, then you essentially see that one more slot has appeared over here. So a list is essentially is helps you create more variables easily, kind of. Okay, and using lists and for loops, you can actually do very powerful stuff, because for loops start indexing from 0, and the for loops can go through all the elements in the list. And yeah, but in the interest of time, I'm only able to, I wish I could give you guys do the Kahoot for lists and for loops, but and do the exercises for them, but I think it's I'm already overshooting the time. So if not, actually before we end off, can I kindly get you guys to fill up a feedback form, right? Yeah, so I'll just send it the Zoom chat. I'll just send it the Zoom chat over here. Oh, sorry. Let me just send. Okay, I'll send it in the group Zoom chat already. Yeah, can I kindly get you guys to fill that up and let me know some feedback on whether the pace of lesson is good or whether the content is too difficult or too easy, but from here, right? Okay, if you guys want more details on A level computing or O level computing, sorry, yeah, if either one of those is you're interested in finding out more about that, or if you're interested in finding more about what university computer science is like and how it differs from what we've just learned, feel free to drop me a message. And if you have any other further questions about debugging, or if you want to access the exercises, the replica exercises, you can pass me your email and stuff. Just contact me on Telegram. You guys have my Telegram already. It's TCH1001. Uh, yeah. So if not, thanks for attending these free lessons. Hope you guys learn a thing or two, and I hope that this sparks your interest in programming and helps you springboard from here to other areas of computer science, or whether it could be even other stuff, right? Coding is a very useful tool in general. It's basically allowing the computer to, it's basically commanding the computer to do what you want. Okay, so if not, that's all for today. Yeah. If you have no questions, I'll be ending the Zoom meeting soon. Thank you. Bye. Please fill up the form. Yeah. Okay. Thank you. Bye. Okay, I'll be ending the Zoom now. Yeah.